All right. Thanks for having me, everyone. So we're back at ETH Denver. It's another year. And what's different this year than last year specifically, what we're going to be talking about today is the continued evolution, the expansion of the modular ecosystem. This thing that this time last year was really just an idea, today, this time in 2024, is really starting to materialize and take shape. So why are we here? We're here, the proximate reason for us being here today is because all of us find these internet computers pretty cool. Sorry, my slides keep moving around. Don't know why. We think they can have a real global impact, and we think that they are the means to perhaps creating a new financial substrate, a new substrate for computation. But by this time in 2024, we've seen the pitfalls of their inherent design. And back to this question of why are we here? Well, the proximate reason is yes, we want to advance this thing. We think it's cool. We think it can have a real impact. But the bigger reason is we're all here because we're trying to increase demand for these internet computers, for these blockchains. Everyone here is probably spending most of their effort, a lot of their life force, in advancing demand for these systems in a way, in an effort to try and make them achieve this global impact that they can have. So depending on the audience, sometimes I go deeper into this. We're not going to have to do that today, but I love this visualization here from Tick Street showing blockchain transactions as different buses and bus lines. Even before they created this, I always thought that the bus line analogy is a really nice way to think about blockchains. Every blockchain is a bus line. Each block is a bus with a fixed amount of seats representing the block size, the gas allowance, the cadence of the buses coming in on that line being the block time. But unlike buses, which kind of take a fixed market price in a first-come, first-served basis, our buses have similarly a fixed supply of seats, but pricing not first-come, first-served, rather determined by the market. And we know what happens. We know what happens whenever we're a little bit successful in our quest to increase demand, we run into the same problem. This problem that in a way is really counterproductive to our entire effort because we increase demand, supply stays the same. Now we run into the same issue each time. The gas is too damn high. The networks become unusable. And we kind of shoot ourselves in the foot with respect to being able to scale this thing to a global impact. So by now, we have two general approaches for how to deal with this problem. One is let's build bigger, better, faster buses, the monolithic approach as some like to call it. The other, the modular approach. Let's create many, many, many more bus lines. Within each type of bus line, let's enable more customization, different types of buses, different seats. And what that's leading for us to create is the early innings of this modular ecosystem. And so where are we with this modular ecosystem? Well, arguably no one's done more for this than Celestia, not just through their technical work to create the first alternative data availability layer, but also through the hard-nosed work of ecosystem building, which I can tell you as someone immersed in this every day, might be just as challenging, if not more challenging, than the technical work of getting this type of thing to work. But it's not just them. It's a wide array of teams, whether it's Arbitrum and Off-Chain Labs, Optimism and OP Labs, each creating their own roll-up framework in Orbit and the OP stack, respectively. The different roll-up providers in folks like Caldera, Conduit, Altlayer, and several others. And just a whole host of different players that are working on these solutions that are advancing the modular ecosystem. So I'd argue that the modular ecosystem has sort of had its big bang moment, its inception of the universe in Q4 of last year. A culmination of events with Celestia's launch, giving us the first live alternative data availability layer, continued progression and maturation from the roll-up frameworks in Orbit and the OP stack, an improving of the offering to become more robust from rollup providers, again, like the Calderas and Conduits of the world, and a mix of different contributions by other players in this ecosystem. All of this serving to make the act of creating a new rollup or chain increasingly easier. So where are we today? Today, I would say that we are past that Big Bang moment and entering the first expansion phase of this universe. In the months since that Big Bang had occurred, what's been happening? As we've entered this phase, we're seeing more rollups and more chains, again, driven by the lower costs to create those chains, the increasing ability to do so. We're seeing more customization and experimentation at each one of these. Where is this going to take us? Coming up this year, we're going to see additional launches for data availability layers with the likes of Avail, EigenDA coming online. And as we continue with this trend, we think as the modular system expands and evolves, we're going to get sovereign rollups, an expansion beyond just the smart contract rollups we have today that are only tackling execution to also include settlement in that. Beyond that, we're going to see bona fide ecosystems building around these new rollups, each with their own merits, their own communities, their own norms. And so where do we get to beyond that phase? Well, I'd say that beyond that, the mere notion of a modular ecosystem in and of itself, that's going to begin to fade. Kind of like if you've ever heard David Foster Wallace's famous commencement speech where he talks about the two fish swimming in water and encountering an older fish who looks at them and says, "Morning, boys, how's the water?" And the fish, they keep on swimming and they look at each other and they go, "What the hell's water?" Right? As this continues, as this expansion builds on itself, everything is going to be built in this way such that stating it, talking about the modular ecosystem in specific terms is going to lose its meaning because it becomes so pervasive. It's like the water that you're swimming in. It's the thing that surrounds you. So how do we get there? Well, I'm here to tell you how we at Hyperlane intend to pour gasoline on this budding modular fire that happens. Specifically, how Hyperlane's permissionless interoperability is going to be the thing that connects all the moving parts in this modular expansion. So I've argued before, may have had, if you've encountered some of our writing, some of Celestia's writing, that I think that talking about the modular stack without talking about interoperability is nonsensical. We just went over how different efforts are making it increasingly easier and easier and easier to spin up a new rollup, a new chain. Whether it's because the cost in dollars, the cost in developer cycles, the cost in time keeps going to go down. Whatever it is, we now have an increasing array of rollups and chains coming online. But what we don't talk about enough, especially when we talk about this notion of the modular stack, is interoperability. Yes, we're making it easier to create your own rollup. Yes, you can get one done in 5-10 minutes. But if it doesn't have interoperability, if it can't connect to anything, you basically created an island in the middle of the ocean. Don't you want to have trade routes between it and the mainland, between it and other island networks? Don't you want to have a path for economic activity? Of course you do. So how is it that we don't talk about interoperability as being a part of this stack, right? Again, that's why I'd say it's nonsensical. So interoperability changes that. Interoperability allows all of these things to connect. But it's not enough. In 2024, I'd argue it's not enough to simply have some way to connect these. You need a permissionless way to do it. You need a way that has no gatekeeping, that preserves the core concepts of crypto, of permissionless and sovereignty. You want to be able to connect without gaping on your terms, however and whenever you want to. And so that's what we believe here at Hyperlane. Hyperlane was built specifically for this world of many, many chains, this world where there's not just a lot more chains, they come to market at an increasing rate. And so we basically ended up building it for the modular expansion before anyone even knew what those words meant. Today, anyone in this room can deploy Hyperlane to any chain they would like. If you're feeling bold, scan that QR code, and what you'll find is a guide for how to use our CLI to deploy Hyperlane between two local networks. If you're feeling extra bold, you could scour the docs and easily find a guide for how to do this on a live network, not just local networks. I'll leave it to you whether you want to do it on a test net or a main net, but have at it. So if you don't already know about Hyperlane, let me tell you about Hyperlane, the one truly open framework for interoperability. So here we have a little schematic of the architecture, kind of going over it at a high level. Again, due to time, we're not going to go deep into the weeds here, but we'll cover the basics. Probably the most interesting thing to know about Hyperlane, beyond the fact that it is permissionless, beyond the fact that it changed how people think about security and interoperability, which again we'll spend more time on soon. Once Hyperlane is deployed on any chain, it can be connected with any other chain. And Hyperlane security works in the outbound direction. So you have a Hyperlane deployment on, say, Ethereum. You have a security module observing that deployment. Then any message going out that is signed off on by that security module, it can be, think of it like a broadcast. That broadcast can then be received by any other chain that has Hyperlane. In that sense, the Hyperlane mailbox function is both a broadcaster and receiver of interchain messages. So how does it work really? A message is constructed by a sending contract, often initiated by an end user, and then sent through the mailbox. A security module, which in just a minute we'll cover that in more detail, observes that mailbox, and if everything looks kosher, signs off on the message. At that point, it can be picked up by a relayer. The relayer is a permissionless role, can be ran by anyone, does not play any role in the security of a message. Pure and simple, a delivery guy, one that can't meddle with the contents of your package. So it sees that you sent something, it sees that it's been signed off by at least one security module, then it takes the necessary information from the security module, takes the message, and initiates a transaction on the destination chain, interacting with that mailbox. If everything checks out, the signatures look good, that message is going to arrive on our destination. Again, anyone can run a relayer. We're even working on features to let users relay their own transactions if you want. If you took my challenge of scanning that QR code earlier, and you're now fiddling around with the CLI, very soon you'll be running a relayer yourself. So what's unique about Hyperlane that makes us so convinced that this is the right way, perhaps the only way, to connect this vast and accelerating modular expansion and do so at scale? Well, it's this notion of modular security for modular chains. So Hyperlane does security differently. Historically in interoperability, pretty much every protocol took this approach of, we have a product on one hand. The actual product from these protocols is the connectivity between chains, the interface for sending some information between two chains. And then tightly couple that with the security mechanism, oftentimes enshrined directly in the protocol, such that the two are tightly coupled and basically inextricably linked. Starting with Hyperlane, this was decoupled. We felt there's no good reason to do this other than, well, it's just how it's been done. People come to these protocols because of concern about security, tightly couple those two things, why not? we've been in crypto long enough, right? Most of our team's going on year 5, 6, 7. And one thing you know is whenever you think you've just cracked things when it comes to security, that you've just designed the state of the art and no one's going to be able to figure it out, you're just a few months, sometimes even less, away from someone more clever with more time on their hands figuring out how to break that thing you wanted. So enshrining a security module never made sense to us. And we're glad that in the year since Hyperlane's launch, we're now seeing other teams taking this modular security approach. So at their core, Hyperlane security modules, all they really are wrappers on some logic that expresses either a state attestation or a state proof. You want to know that you can read state from another chain and act on that state, and you want to have something telling you why you should trust that state. Now, whether it's, you want to use some validators that you know and trust to secure your message, trust their authority, go ahead. You want to ask them to put up a stake and provide economic security, whether it's your own or it's inherited through ETH, through EigenLayer, through something like a Hyperlane AVS, even better. You want to use that groundbreaking new ZK technology. All of those can be expressed as Hyperlane module. Now, in the case of Hyperlane, an integrating developer always has the choice of which module to choose from. You're defining how you send messages and how you receive them. And when you define how you receive them, you say, hey, I want to use this module or this aggregate of modules or use this custom logic. In crypto, we generally use the same security regardless of the context of what you're doing. Transferring $10, transferring $10 million, sending a governance message that will completely upgrade the protocol, or you're just initiating a simple deposit, everything goes to the same. Why is that? Why should the same security protocol be enforced at all times, irrespective of context? If there's one thing banks do right, and no one dislikes banks more than myself, the one thing they might do right is this exercising of context-based security protocols. They treat you differently when you want to withdraw $50 and when you want to withdraw $50,000. And you want to close an account, they're going to treat you very, very differently. So what does it mean for someone who's building with Hyperlane right before we get into these use cases? Any type of logic can be wrapped. As long as it provides a state attestation as a state or a state proof as a module, anyone can build a module. And once they've done so, any other developer that integrates Hyperlane can benefit from that module. So you can see how a real network effect in the provisioning of security starts building around these security modules in Hyperlane. So let's talk some use cases. I could do the thing where I could tell you, hey, you could do this with Hyperlane, you could do that, and you can imagine. But let's talk about what's already here, because it's 2024 and it's already a bit more advanced. Aave is using Hyperlane for their interchain governance. When the protocol sees a governance change emerge on the parent, on Ethereum, it uses Hyperlane to message that to Aave deployments on other chains alongside Layer 0 and CCIP. Superform is providing access to yield in an interchain sense. You deposit on one chain and it can earn yield on a number of chains. Mitosis, providing users with access to interchain liquidity. So, again, in the interest of time, I'll rush a little bit, but what's the end game for something like Hyperlane? Well, we talked about how it's an open framework for interoperability. It's not something that one team can build on its own. And in fact, to date, it's already benefited greatly from external contributors. Hyperlane today is implemented and most robust on the EVM, but it's also live and in production with CosmWasm and with the SVM, the VM for Solana. It is about to go into production for the MoveVM. All three of those efforts were either taken to completion or initiated by external teams of contributors. If you're interested in looking into this, check out our bounties, check out our repo, and give it a look. If you're looking for your next job, Our most recent hire is someone who built a ZK module for Hyperlane, picking it off the bounty board. Another is someone who joined us after winning several hackathons, hacking with Hyperlane. Hyperlane is absolutely open to any and all external contributions, and those are what will help us get to that end game where Hyperlane can facilitate seamless inter-rollup interoperability, can facilitate one-click hosted deployments for those who don't want to deal with self-hosting, and can really bring about a seamless interoperability in an expanding modular universe where the number of chains just keep going on and ticking up higher, much like the US national debt. So I hope you enjoyed this. If you have any questions, don't hesitate to reach out, join our Discord, follow us on Twitter, send a DM either to myself or anybody else, and happy to tell you more about it.
Hey all, good morning or good afternoon. I'm Guy Tzchaki. I'm the CEO of Phoenix, and I'm going to talk about MPC, ZKP, FHE, and even a sprinkle of TEs, and in the context of which cryptography to bet on. Before starting to talk about the different technologies, I just want to give a brief overview about myself. I'm not a crypto native guy. I used to work at Intel for many years. Recently left Intel, and my job at Intel was the director of homomorphic encryption. And as part of the day job, I had to meet a lot of people out there. Some of them were developers, but some of them were just business-oriented. And every time I tried to explain the difference between ZKP, FHE, and MPC, I got a really vague look on their face. So I decided to try and explain this systematically, but actually try to keep it at a bit of a high level to make sure that people do understand. Now, we've all heard about these three-letter cryptography, some in the context of scaling, some in the context of privacy. I'll try to make a little bit of a order in that space. So before explaining what these cryptographics are all about, I want to take a minute and just explain why do we care about them. And I'm going to talk about it in the context of data confidentiality. So every time people hear about data confidentiality, they think about privacy, they think about protecting the users, and it's all true. But actually, we believe at Phoenix that there is a massive problem on the blockchain space today, which is that everything on-chain is public. Now, for some people, they may see it as kind of a feature of how blockchain works, but what I believe is that actually this is a limiting factor. And the reason is that this doesn't just expose users to their data being public. It also reduces our ability to develop new use cases that can actually grow the blockchain ecosystem. So I'm going to talk a little bit about a few examples, and then I'm going to talk about the different solutions. So I'll start with ones that are actually quite easy to understand, and I'll take an example of confidential transactions, where we're doing transactions on the blockchain. Everything is on-chain. You can actually see everything that's been ongoing there, which exposes users. And if we can get encryption on-chain, we can actually enhance the user security. If you take another example of on-chain gaming, like poker, that can't really operate in a trusted way if every bet that you make is public on-chain. And all the way to confidential voting, which I don't think I even need to understand why you need encryption on-chain. But this is just, I would say, the basic use cases. Things start to become way more interesting when we're going into the DeFi space, when we're trying to look at problems like MEV, when you want to look at solutions for MEV. And today, there are two paths to solve the MEV challenge. One is by encrypting the mempool, which clearly requires encryption. And the other path is also by using MEV auctions. And even then, when you do auctions, you need to have encryption to make the auction viable. And there are compliance pool and decentralized entities and account abstraction. All of these use cases would benefit from encryption and data confidentiality. So let's start about the cryptography that people heard the most, which is zero-knowledge proofs. I want to make sure that I use the term zero-knowledge proof versus just ZK, because people tend to forget that ZK is actually a proving mechanism. So what ZKP is, for folks who don't know, it's basically a cryptography method that enables one entity to prove to another entity that they know something without actually revealing what it is that they know. Kind of hard to understand how you can achieve that, but if you take that example that people typically tend to provide, which is an entity A that has two balls in their hand, one blue, one red, and another entity that wants to show that entity that they know they have balls with two different colors, but without revealing that they have a red ball on the right hand and a blue ball on the left hand, What they can actually do with ZKP is tell that entity to take the balls, put them behind their back, and flip them, or not, and show them again. And since they're able to see the color, they'll just be able to say, yeah, you've flipped them, or you've not. And if you do it a several amount of time, you can actually prove that you can see that this entity has different balls in their hands without actually revealing the colors of the balls. So that's like a very basic example. But when we think about ZKP in the blockchain space, typically it's being used in two domains. The first one is the one that everybody heard about, which is in rollup validation for scalability, being used by Starknet and zkSync and Scroll and Polygon. But when we start talking about using ZKP to address data confidentiality, it is actually quite limited in what it can offer. Because remember, ZKP is a proving mechanism. It does not enable you to do computation on data while it's encrypted, and as such, can provide confidentiality to a very small amount of use cases. If you want to do auctions, if you want to calculate on data that's coming from multiple entities, ZKP is not the solution. Another cryptography that's being mentioned is multi-party computation, or MPC. And MPC, in short, is basically a technology that enables a group of different owners to jointly compute a function of their private inputs. In layman terms, we can take a private key, take this private key, split it into shares, and then have each party do computation with that share. And only once everybody has completed their computation with that share, then the computation itself can actually be executed. MPC today in the blockchain domain is used mostly in digital asset custody wallets with Fireblocks and Zengo and Coinbase and others. And the reason is that it has a limited set of entities. Let's take the scenario of a custodian that you don't necessarily want to give a custodian full control over your private key. You actually want to have the ability to sign it and have another entity sign it together with you, and only then the transaction will be executed. That's where MPC is being used, and it's being used quite widely. The problem with MPC is that it requires significant communication and the bandwidth, especially when you're trying to work on the internet. So it is limited to use cases with a small set of participants. This picture here is taken from the storm last year in I-5, Portland, where I'm at, and I was stuck 4 hours in that storm in the car. So I'm not saying MPC takes 4 hours, but it is definitely slow and limited to a small set of users. And not to forget, there is also trusted execution environments, TEEs, which are a secure environment, typically within a CPU, that enables you to do computation in a secure fashion inside that trusted hardware. TEEs are great, they have good performance, but their security guarantee is lower than a cryptography guarantee, and they're prone to side channel attacks. So now I'll introduce the new kid on the block, and that is fully homomorphic encryption, or FHE in short. What FHE is, for those who don't know, is really a very novel cryptography. Actually, anybody who Googles FHE will see the term. It's the holy grail of encryption technologies. Because what FHE does, it enables you to do computation on data while it's encrypted. Take a minute and absorb this. You can do computation on data while the data is encrypted. So unlike any other encryption technology that requires you to decrypt the data before you can do computation on it, with FHE, you can actually do the computation on it. So how does it work? I've tried to explain to many people how FHE works, and I try to use like elaborate mechanisms, and I think everybody after 30 seconds just went to sleep. So I'm not going to try and explain it in a mathematical representation. I'll give an example, but I do want to make sure that people understand that the fully homomorphic encryption comes from the mathematical terms of homomorphism, which basically means that you're maintaining the same mathematical formation when you're moving from one structure to another. So I thought hard about the best way to explain what FHE is. I was on the plane, I saw Spider-Man enters the multiverse, and I thought, you know what, that may be a good example. So in essence, what we're doing when we're encrypting data with homomorphic encryption is we're basically transitioning it from one domain to another. The data is encrypted, but it actually maintains the same mathematical values that it has before the encryption. So given that we're maintaining the same mathematical formation, we can now actually do computation and after that decrypt the data. It's very similar to like when Spider-Man crosses the multiverse, so that's like the encryption part of it. When he's in the other realm, he's still maintaining the same formation. You can do whatever you want with Spider-Man, and then when he comes back, he gains all the insights that he learned and at the other realm. So why do we care about FHE? Well, as I said, it's the holy grail of encryption. It's been discussed for many, many years, and there's been constant progression around FHE, actually. People tend to think that it's slow and compute intensive, and it is compute intensive, but there has been constant progression that actually makes FHE ready for prime time today. But the second part of it, it's actually that it's very easy to use. So with Phoenix, we're supporting Solidity, so we're EVM compatible. We're using a library from Zama. And what you can do as a developer is basically just use the same Solidity language that you use today, but you just have an additional function to encrypt or decrypt assets. You don't need to learn a new language. You don't need to understand what FHE is. It's basically just an ability to encrypt and decrypt very easily and very natively. Now, it's not just us that are excited. I think the market shows that. I've just put a picture here from the Masari report about top 10 trends to focus on in 2024, and FHE is one of them. So it definitely is transformational and going to make a whole lot of new use cases maturing. So in short, I'll talk briefly about Phoenix, and then I'll give an example of how all of it glues together. So Phoenix in itself is a layer 2 Ethereum compatible platform. We're built on top of the Arbitrum stack, and we can actually enable computation over data while it's encrypted, Solidity-based, very easy to use. So who should I bet on? I talked a lot about FHE, and maybe you think that FHE is the best solution, and I do think it's great, but actually, for solving the challenges, we need all three of them. We need the combination of ZKP, FHE, and MPC. And the reason for that is that we need zero-knowledge proofs to prove the correctness. So when a user encrypts data, we want to make sure that the data that is encrypted is proved and is verified, and that's where ZKP comes into place. We need FHE to do the computation on the data while it's encrypted, and we need MPC to protect the network key. So with that, I'll give just one example of private voting. We'll take an example of a private voting contract that initializes a new private and public key pairs. These private keys never exist in one place, thus usage of MPC. The users can encrypt their votes with 1 or 0, and that is through using the homomorphic encryption that I described. We use ZKP to prove that there is actually no double spending that's happening. And we have the validators that can actually tally all the votes without seeing these votes. And that is the usage of homomorphic encryption again. And at the time of reveal of the results, basically the validators decrypt the votes with no other data gets leaked. And again, this is using MPC. So with that, I'll end here. More than welcome to come and ask me questions after the presentation. Follow us on Twitter. And thanks for joining.
Hey everyone, good afternoon. We're going to get started here. Thanks for coming. Wanted to talk to you all today about DAOs and where they are and where they're going, especially related to multi-chain DAOs, how all this new, the scalability roadmap that is playing out, how it affects DAOs in particular, and maybe also some generalizations about how the multi-chain roadmap affects all kinds of applications, not just DAOs, but what are the general takeaways we can learn from how DAOs use the new primitives enabled by multi-chain tech, and also the challenges that they face in managing all this complexity from multi-chain use cases. I can start by introducing myself. I'm Raf, co-founder at Tally, which is an application that helps DAOs manage all their on-chain complexity, so especially around proposals, voting, managing voting power, launching a DAO, managing all the money. Often a DAO is managing a protocol like ENS or Uniswap or a rollup like Arbitrum. These protocols are all run by DAOs. The token holders and the token voters directly control the protocol upgrades and the treasury disbursements using smart contracts and front ends like Tally. And I want to maybe start by talking a little bit about the tech layer of how these smart contracts work, just because that'll be relevant for the rest of our talk. The talk, I think, will cover both why DAOs might want to use multi-chain tech, and also how it works. Like what under the hood is happening at the smart contract layer and at the UI level to build these multi-chain applications, because they're still fairly new. The scalability roadmap, the roll-up-centric ETH roadmap has only just started playing out over the past year or two. And then once we have multiple chains, we need bridges and ways to move state and move value between those chains. And once you have those primitives, only then can you start building applications like, for example, a DAO application on top of the interoperability stuff. But before we had many chains, most apps were just on one chain. And that was also true of DAOs. So these DAOs, this is a standard set of DAO smart contracts that was popularized maybe 4 years ago, starting in 2020, and has since become a very standard setup for the way that on-chain DAOs work. So they have first a token contract, which is a normal ERC20 token with one extension, which is the voting module. So like in any normal token contract, it keeps track of token balances, which account has which token balance, but also the voting extension keeps track of voting power, which is an additional parameter on top of the token balance. So rather than DAOs using token balance for voting, the token balance has to be activated if it wants to participate in the DAO by delegating the token's voting power to either yourself. You can delegate to yourself, or you can delegate to somebody else who will maybe be more active or more involved or have some expertise, and you want them to, you trust them with your voting power. They're going to vote on proposals. They're going to use your token's voting power to do stuff in the DAO. And the token contract handles both of those two things, both keeping track of everyone's balances and also keeping track of who's delegating to whom and how that affects voting power. The second contract here is a governor contract, and that is the contract most responsible for the DAO operations. So this governor contract has rules for like what is a valid DAO proposal. It manages the life cycles of these proposals, like when they go up for vote, when the votes actually happen. The governor contract counts the votes. It determines if a vote passed or failed, and it keeps track of the actual executable call data that a proposal will execute if it passes. So there's a proposal, as you may know, has two parts. There's a human readable description, which is logged on chain, and also the machine readable part. So a proposal generally does stuff. It can execute any call that a normal account on Ethereum can execute. A proposal can do that too, which makes these DAOs very generalizable and very powerful. And then the last contract you see down here is the time lock contract, which does two things. One, it's the account of the DAO. This is the contract that's going to hold the balances of any assets the DAO has. It's going to have all the permissions the DAO has. If our DAO operates a DeFi protocol or a scalability protocol, the admin of that protocol is very likely to be this time lock contract. That's how DAOs like Uniswap or Compound work. And together, we have these 3 contracts that each have their own responsibility, and they do separate things, but they are pretty composable, pretty modular, pretty standard. And there's lots of interfaces, such as Tally, that play nice with a standard like this. So you can launch a standard DAO with contracts like this, and then use it on multiple different front ends because of the widely adopted standard. But remember, this is only single chain. This pattern was designed about 4 years ago when the interoperability roadmap had not started, the scalability roadmap had not started to play out. But there were these successful protocols run by big DAOs, like Uniswap, like Aave, like Compound, and the protocols needed to start going multi-chain. Uniswap needed to deploy their pools and their pool factories on not just Ethereum, but Polygon and Optimism and many other chains. And same story for the lending markets like Aave and Compound. But they already had their DAO anchored in one place, and they had to solve this problem of who updates the risk parameters of Aave on Polygon. How do we set the fees for the Uniswap pools on Optimism? Especially since they had already promised that there was a token on Ethereum and that token would govern the protocol. They had to figure out a way to govern the protocol, which now existed on many chains, from their DAO, which was only on one chain. And luckily, that wasn't that hard. Because we had these very generalizable primitives, the governor contract could make proposals that just call any function in Ethereum. They could call functions like pass a message across a bridge. The governance would make a proposal to pass a message across a bridge to some other chain. They would send a message to Uniswap on Arbitrum, and they could change the fee tiers or change the fees for the Uniswap protocol running on a totally different chain than the Uniswap DAO. So this is what I would say is the first step, the phase 1 of multi-chain DAOs. And this has been happening for years. Aave's first cross-chain governance proposal is this headline here from, maybe it's too small to read, but from February of 2022. So this was already a couple years ago. DAOs existed as multi-chain organizations. And Uniswap last year did a lot of work to figure out what bridges were the right ones for the different types of Uniswap deployments. They've done a lot of thinking about how to safely and sustainably scale the Uniswap protocol across many different chains. And luckily, they had a pretty clear technical path to implementing that. They just needed to start making calls across bridges. It didn't require any big smart contract changes. There was a pretty modular, composable way to do that from existing building blocks that worked, the existing DAO contracts, the existing bridge contracts. And there were certainly UX challenges. The fact that you had a protocol across many chains and that we're making these calls across bridges. There were just a lot more states that a transaction could be in. It could be not yet sent. It could be in flight. It could get lost on the bridge. It could be confirmed on the other side of the bridge, or it could have failed. There could be an error on the other side of the bridge. So there's a lot of lot more cases to worry about, but those were fundamentally challenges that were solvable with better UX, better polish, better error handling, not a huge change to the security surface or to the smart contracts. But that was not fully, that system, which has been working for years, and this is kind of the contract picture of how the existing DAO contracts we saw in the first slide just plugged in some bridges on the bottom, and now they can govern a protocol on many different chains. But this doesn't fully take advantage of all of the new stuff that's possible with multiple chains, each of which have different parameters and different trade-offs. there's lots more reasons we might want to go multi-chain. After we've taken our protocol multi-chain, we may want to think about how we might take our DAO multi-chain. We talked about in this at the beginning about we might be pulled there, right? Our protocol is moving to different chains. We want to govern it wherever it may be, and that was the first part of the DAO that went multi-chain is sending these calls. But now that lots of different networks all over the place have different trade-offs, there are lots of good reasons to start pulling apart those three contracts we saw, the token, the governor, the time lock. We can start pulling pieces of those to the chain where it makes the most sense to put them, based on whatever trade-offs that we have here. So, for example, gas is a lot cheaper if you're not on Ethereum mainnet, but you're on a rollup or even a layer 3, someplace with very cheap gas. And voting on-chain does get expensive, especially on mainnet as mainnet gets more congested. So we've seen that be a big draw for DAOs to start thinking about how they can navigate a kind of security and scalability trade-off. These rollups, especially with different data availability strategies, can have very cheap transactions, but we might not want to put the root of our DAO contracts there. Maybe we want the root of our DAO contracts on someplace very secure, like layer 1 Ethereum, and then the cheaper things like voting could move somewhere somewhere more scalable, somewhere much cheaper, and then we can bridge the results back to the rest of our DAO on layer 1. So this is, I think, a pretty generalizable pattern for all application developers now that we've got a whole menu of different chains with different security and cost trade-offs to choose from. So as our applications get richer and our use cases expand, we're probably going to need to pick and choose between whether we want some actions to live on expensive and secure chains and other actions to live on cheaper chains that maybe make different security trade-offs. And then there's also plenty of go-to-market reasons why you might want to be on many different chains. For acquiring users, it's a lot easier to meet users where they are. If they already have a wallet installed on a new network, they already have gas in their wallet on that network, they already want to do something composable, right? They already want to do some swaps or buy a name or use a bridge. Your protocol and your DAO will have an easier time if it meets them there, where they already are, than trying to convince them to migrate their state, add a new network to their wallet, and go get gas in some new chain. So it's just a lot more convenient for users to meet them where they are. And the nice thing about having a multi-chain DAO is you can do that. You can just be in the same chain, the same network that a user already is, whether that's for ease of use, or sometimes it's also for alignment. There are lots of very large ecosystems and communities that are very excited about particular networks or particular rollups or particular layer 3s. And if you're starting a new project or you're a project going to market on a new chain, being able to be aligned with the ecosystem that you're trying to build on is a very powerful go-to-market tailwind. And the fact that a DAO can now be multi-chain makes it a lot easier for these projects to go figure out the best place for them to grow and not be tied to the chain that they started on and not be tied to one chain, right? They can expand across lots of different ecosystems with lots of different activity and people doing interesting things. So that's the reason why we might want to go multi-chain. And then I wanted to also talk a little bit about how we do that. What is happening under the hood? What do the smart contracts look like? And what do the UI look like to actually get there? So to start, wanted to talk about how the token contract goes cross-chain. And then we can break it out and talk through the other parts, the governance contracts, and eventually we'll tie it all together. So the first thing we have to do is, if we're going to have a cross-chain DAO, we have to have voting power and tokens on the different networks that we want our DAO to to support. So the hub token, the way we're going to do that is with a hub and spoke model. So we'll have two. Let's start with 2 chains, and we could generalize it to more than 2 chains later. But there's 2 chains in this simple example. The hub chain is where the main token lives, and then the spoke chain, or in some cases, multiple spoke chains, are where users can bridge that token. And tools like Wormhole can make that bridging very easy and very seamless. Like they have great native tooling for bridge tokens to live on the other chain and seem like a regular ERC20 token to the users when they hold it on that chain. And the way that works in our DAO example is the hub token is a normal DAO governance token. It just has one upgrade, which we'll talk about in a second, that lets us lock the tokens in a bridge, and then they appear on this spoke chain. And on the spoke chain, lots of people can have balances, and they don't have to worry too much about what's happening on the hub chain. And similarly, the hub chain doesn't have to worry about what's happening on the spoke chain. It just knows that there's some tokens locked in a bridge over there, there's something happening, and it's all good. And because it's a governance token, we also have to, on both chains, keep track of the voting power. But we don't need a global view of the voting power. Each hub or spoke can keep track of its own voting power and its own delegations. And that secret sauce, that module that we can use is called flexible voting. It's an extension to ERC20 governance tokens that was built by Scopelift, a team that's built a lot of the smart contract tooling for governance. And that lets us vote on a spoke chain and then aggregate those votes. Maybe every single vote we could send back to the hub chain, or it would be a lot cheaper if we didn't send them back one by one, but we batched them up and send them all back together as a voting total to the hub chain. And that's the that's how we can split up. That's the interface boundary between voting on a spoke and voting on a hub. So the next thing we have to move to our other chain is the governance itself. So the hub governor can actually remain the same as long as it has this flexible voting module. All it has to do is know that some of the hub governor's tokens are locked in a bridge contract on the hub network, and that sometimes messages will come across a message passing bridge that say, here's some votes. 10 votes yes and 100 votes no happened with the locked tokens, and the hub governor just updates its voting tally whenever it gets a new message. And that's the version with 2 networks, but it also generalizes. We could have many networks. So you could have a single hub and a bunch of different bridges, and at the other end of each bridge, you have a bunch of different spokes, rather one spoke on the end of each bridge. And we can get a lot of coverage this way. We can take these pretty simple primitives that are battle tested and well known. We add some small extensions, and then now we can slowly generalize a small, simple working system to a larger and larger, more complex working system that lets us solve for the problem of how do we take our DAO multi-chain. So to review, once we put these pieces together, what can we do? What user benefit or DAO benefit is there to adding some new complexity, adding some new tools and bells and whistles? Well, like we could do before, we can still govern a protocol on multiple networks. But importantly, we can take a DAO that's on a single chain that's maybe pretty expensive. We can give the users the option to move their tokens to a cheaper chain and vote there, save a lot of money. And importantly, we can also expand our token to a new network. So maybe a DAO wants to generate tokens for some incentive program on a new network where users are using their protocol. They can do that with this setup. And they can even do that on day one. If you have some protocol that's used or some application that you want to be used across many different networks, you can launch that token, either the hub token or the bridge token, all over the place on many different networks. So that was hopefully a comprehensive overview of, at a high level, how all these pieces work and how they all fit together. But I'm happy to answer any more questions if you have them. You could shoot me an email. And I also wanted to share some docs put together by Scopelift about flexible voting and by Wormhole about the token bridge docs and the relayer tools that they have built that powered this whole system. So I think this is a great example of pulling together different small primitives that are composable to build an application that both solves users' problems and solves business problems. And hopefully also is an example of the kinds of things that we can build with multi-chain tooling to build multi-chain applications. So that's all I had for you today. Thanks for listening, and happy to answer any questions after the talk if you have any.
And we're live. All right. Good afternoon, ETH Denver. I guess it's afternoon, just barely. I am Dean Tribble I am CEO of Agoric, which is a layer 1 Cosmos-based L1 that with integrated IBC, inter-blockchain communication protocol, for building smart contracts in JavaScript. The idea is, of course, to be able to enable the millions of developers out there in Web 2 land and beyond to build smart contracts. And it's not just JavaScript, which is a language, it's the power of JavaScript, which is a framework. So a framework for being able to easily mint and trade and build interesting components and abstractions for doing smart contract, for doing DeFi, for doing NFTs. And in this case, as it turns out, the ability to do that in an async world is incredibly powerful and timely. So let's talk a little bit about that and then how we achieve that. So roll-ups, layer 2s, Celestias and dimensions and sagas and all these things that enable quick creation of chainlets and applets and all these things have succeeded, right? App chains have succeeded. There are lots of them out there, thousands of them literally, with their own tokens, and we have created this network of connected assets and services. So we've succeeded at that to the tune of $2.2 trillion in liquidity across these systems. Right? And that's really powerful, and that creates the multi-chain world and the multi-chain problem, right? What do people have, right? They've got fragmented liquidity as a result of this. They've got an overabundance of choices, where a user coming in that wants to do something simple, and you go, well, which ecosystem would you like? Which of these 100 options of chains would you like to subscribe to? How many accounts do you want on there in order to do portfolio management across that perp chain and that AMM chain? And the answer is, they go away and do Web 2 instead. So we've got an overabundance of choices, and if they do try and do something, I've got US dollars and I want staked TIA over there, they've got to manually shepherd their assets through multiple bridges and conversions in order to accomplish even very simple cross-chain use cases. Right? What they want is seamless access to multi-chain liquidity. Fragmented liquidity, not their problem. They want to be able to have some of their assets on Ethereum, some of their assets in Solana, some of them in Cosmos, etc., and not care about the difference any more than when you order a hamburger with an application on the phone, you don't care which cloud system the application is running in, you just want your hamburger delivered, right? So they want a uniform entry point. I'm not going to go, oh, should this be Solana? It's like, I'm going to go to an app, the equivalent of Robinhood or the equivalent of one of these Web 2 things, and I'm going to start doing my thing. And if you can't deliver assets and value from all these different chains, then that app is not going to appeal to the broad range of users out there. And they want that simple user experience. They want to click on a button and get a hamburger delivered to their doorstep, figuratively. They want to click on a button, take their dollars, get staked TIA, get staked Osmo, get a loan to go out and buy something or double down, or be able to pull cash out and go buy a car, right? So the solution to that, right, the vision that people want is chain abstraction, right? We don't want the chaos of many entry points. Users don't want that. What they want is a vision that's now broadly being called chain abstraction, which is this seamless access to digital assets and digital services across Web 3. But to build that is hard. You need the ability to orchestrate the activity of all those things, to shepherd assets from one chain to another in some way. There are many solutions that people are trying to tackle this, but most of them are off-chain, right? I've got a effectively cloud-based Web 2 service that's going to sell my asset over here, hopefully not rug pull my asset, and go deposit it over there. That's not great. We built Web 3 for a reason. We want the integrity of execution of running those kinds of behaviors on-chain. And that's what orchestration is, the ability to program all these asynchronous assets. And how do you do that? Well, in the mainstream world, JavaScript is the orchestration language of the internet, right? It controls trillions of dollars every day. That's what people know how to build with. And so orchestration is that set of capabilities to be able to coordinate these assets and services across these chains. So how do we accomplish this? In JavaScript, right, what you do is, okay, we've got blocks across the bottom. most blockchains, everything happens in a single block. You got 5 seconds, or depending on the chain, 20 seconds, or a half hour, whatever it is, but you've got this tiny little segment in order to get something done. Anything you're doing cross-chain does not fit in a block because you got to go off-chain. Anything you're doing to cooperate or do activity across multiple services doesn't work in a block. You've got to go off-chain. You've got to be spread across blocks. And so an Agoric smart contract is a long-lived process running that can do async await. And we'll talk a little bit more about that, where it can send a message to a DEX over on Osmosis using IBC in order to trigger a transaction and wait for the response and react to the response in very simple, normal, familiar programming styles to then issue a message over to Ume to trade with it, or to build a vault in interprotocol, or to go across Axelar over to Aave, or whatever it is, in order to trigger a transaction, and then finally maybe send it over to ETH to go buy something, or to go put it in Uniswap, or whatever it is. Right? That ability to have a long-lived program that a normal developer would understand, and that in the next generation of smart contracts, a normal developer had better be able to build, that's what we bring to the table. Right? So, oops, went the wrong way. So what's that look like? This is a developer event, so I got to show you code. Let's just set up some things. Looks kind of familiar, right? I want to transfer $1,000 that I have on Ethereum. I want to go buy TIA, Celestia's token, and stake it. That's what I want to do, and I want to do that on chain. I want a service that does that for me, so I push button and magic happens. I do one signature and multiple chain actions happen, right? So in JavaScript, I get the chain object that gives me all the services available from Agoric that are reachable on Celestia. I create an account, so now I have a new account controlled by this smart contract, uniquely here for this user. Oops. And now I'm going to do what's called, Cosmos happens to have a onion routing mechanism where you can say, okay, start a transaction that goes to that chain, and then that chain, and then that chain. It's hard to program normally. Here, I can just do it in one place. I write it all up. I say, I want something that will swap on Osmosis TIA for US dollars for TIA, and then send it on to my TIA account, my account on Celestia, right? Pretty straightforward. We don't need to go into the details here, but millions of programmers would trivially understand that. And then I say, okay, Noble, my account on Noble, which is the native USDC deployment for Circle in the Cosmos ecosystem, where I sent money over Ethereum and said, go put it on Noble, and then something better happened with it, right? Well, this thing will then pick up my money and send it through those hops. So it's going to take my USDC on Noble that just got delivered from Ethereum, send it over to Osmosis, trade it for Celestia token, send the Celestia token over to Celestia, and once that's done, await that, and this could take, a few minutes, a few seconds, a few days, whatever it is, depending on these services. If you're like unbonding a token as part of this process, something, right? And it will await that, and once that's done, it goes on to the next line and says, okay, let me get the balance from TIA. How much arrived there? How much do I have in my TIA account, in my Celestia account? Stake that. Delegate that to my validator. And all of this is a small handful of lines of JavaScript that any of millions of developers could understand, and that you can deploy and run in a durable fashion on the Agoric chain, where it can all be upgraded and survive chain updates and all those kinds of things. That is the superpower that Agoric brings to the table, is that ability to to have contract operations that span blocks, that are not just instantaneous trades. Don't get me wrong, instantaneous trades are wonderful. We have succeeded beyond people's expectation, mostly, in terms of being able to deploy that and do financial services on top of that. But the next level of application requires something more than 5 seconds at a time, right? And that's what this brings you. Okay. So, I'll do one last thing there. And so the tokens, the contract's all running on Agoric, but the tokens flow, the asset, the fungible token flows from Ethereum to Noble to Osmosis and finally to Celestia, and the user just signed one transaction, right? They didn't have to do all of this. They just authorized this to happen on their behalf, and now this application is in a position to manage their position on TIA. So, you've got this fundamental ability to do multi-block actions. Oh, and that previous code looks familiar to a lot of people. The difference is it's running on chain, which nobody else can do. Right? So you've got this ability to do these multi-block actions, to react to things and wait for them to happen and then respond to them. And that's not just respond to the events of I sent a message and I got a response back. We have native timers, so you can do periodic events to charge interest or to do continual purchase or to rebalance your portfolio every week or whatever it is that is this cross-chain action you would like the system to proactively do, that can be built. And these are abstractions all written in JavaScript, which is part of this extensible component framework. So adding Wormhole, adding Axelar's GMP, integrating the functions that Squid has added to that, easily and straightforward, and they fit within the same coding paradigm of, wait for this transaction to go over to Filecoin and buy a position so I can store my contract data or store my NFT data. Okay, so we are rolling out the MVP of these APIs, coming in hot and heavy this quarter. So that's showing up starting in March. And you can look at what we're doing and see the updates as they come by going to agoric.com orchestration. And that encompasses, right, fungible assets, the governance tokens, liquid staking tokens, stable tokens, non-fungible assets, it'll encompass in a future version positions, NFTs, PFPs, rental units, all these real-world assets, all those kinds of things. Again, making them programmable across chain, so you can have a portfolio of different positions on different chains or actions that move and transfer and work across these. It can use these remote services, right? In an app chain world, in a multi-chain world, there are multiple dexes with different yield for different positions, and it changes over time. You want to be able to write programs that span those. These are all services that when it pops up on one chain, no chain is an island anymore, right? You want that service that's over here to do swaps to be accessible from a program over here that has assets that you want to go participate in that pool, right? And Cosmos has been doing that for now literally years. The rest of the world is now in a position to be able to leverage the same kind of stuff. And then there's, of course, the infra. All of these are components that participate in orchestration, that are now part of that multi-chain world, but they need software to tie them together and deliver simple applications and simple use cases to users, rather than complex things that users can, a few of them, degens and people dedicated and traders can make their way through. We want normal users to be able to do normal things using Web3. So, those use cases, right? Stablecoin yield maximizer that will dynamically rebalance your positions in different stablecoin yield functions across different chains, across different ecosystems. Cross-chain vaults, where I can, instead of taking the token from here and moving it across a bridge to my chain in order to operate it, I can lock it up over there and use the proxy here to be able to trade the rights to it without ever moving it off-chain, right? And that works for NFTs in the future as well. Stake manager, where I've got assets that I would like to participate in that purchase, or I want to incrementally do so. Unstake those, and 21 days later, or 14 days later, or whatever it is, pick it up and do this thing, because you know what, I'm going to be on vacation then, or that's 3 weeks later, I'm never going to remember. I just want to do this operation, you make it happen, you figure out what it takes. And then finally, contract swap aggregator, right? In the Cosmos ecosystem, there are multiple dexes. Over various bridges like Axelar and Wormhole and Gravity, you can reach even more dexes in Aave and Ethereum and Solana. Being able to have something that will trade in the best place for those, when your contract needs to make a trade for an asset in order to go stake it or whatever it is, go find the best place, do the trade on chain, and make it happen. Those are all things that we want to be on chain, and until now, you couldn't really do that. And so, not just are all these pieces things that people here are already building or have already built, right? If you've got a chain that's built in Cosmos, that's built in EVM, that's built in Solana, you have assets that could be more programmable, could be more accessible, or could be used in services that are not on your chain. Absolutely, that's a worthwhile thing to go build. Add that JavaScript layer that everyone in Web 2 adds to their underlying system in order to make it easy to orchestrate all the activity across those applications and everything else. So participate in the hackathon. Come build apps. There are multiple, obviously we're in the midst of a much larger hackathon, but this is focused on these multi-chain use cases, focused on building projects that span more than one chain, or projects that leverage the value and services on one chain in order to deliver value somewhere else. So come join us in Q2. that'll be rolling out very quickly. And on that orchestration page is where all the details are. Thank you very much for listening, and I'm happy to dig into technical details either now or later on up online. Thank you so much.
Hello, hello. You guys can hear me over there? All right. Thank you guys for being the brave ones. So first of all, a little bit about me. So my name is João Reginato. I've been in the stablecoin world for over 6 years at this stage. I used to work for Circle for 8 years, and in August last year, I joined M0 Labs. And at Circle, I led the build out of USDC and led the product teams around stablecoin and all the products involved in it, not only USDC, but also Eurocoin and the cross-chain transport protocol product that was built as well. So I have a little bit of history, and I have a passion in particular about interoperability because I always come to stablecoins from the perspective of them being infrastructure a lot more than a retail product that people are aware of it. I think that's just the tip of the iceberg. And since we live in a world that is completely non-interoperable when it comes to stablecoins today, I'll talk a little bit about what we're doing at M0 and an attempt to improve that. So first of all, there you go. First of all, let's look at the market as it is right now and think about the dynamics a little bit. I think again, this is not news for you all, I'm sure, but this is the data as it's taken from this morning. So, and I'm looking here at really only the dollar-denominated stablecoins that are backed by fiat collateral, right? So off-chain collateral. I'm discounting everything here that's based on crypto collateral, whether they are endogenous or not. We qualify those as a little bit more experimental. These products are pretty robust. They're pretty established. But the picture of the world that we have today is a world that is very, very highly concentrated in the hands of USDT, as you can see. And if you consider just the top two issuers between Tether and Circle, they hold over 95% of the market share. What are some of the characteristics of the market today? So it's about 130 billion in size. Again, discounting sort of the crypto native stablecoins, which add about another 10 billion to it. It is reasonably fragmented. So there's actually 22 live products today as far as, again, off-chain collateralized dollar-denominated stablecoins. But it's highly concentrated. So despite there being 22 live products, the vast majority of the market is taken by just the top two issuers, and even more if you consider the top three issuers then. All of these models are what we call single issuer models. So they're very centralized. They're not, they don't align with the ethos of blockchain and crypto at all. And we're going to talk about why that is not. And I'm part of the problem, right? I helped create the second largest, but I recognize that is an issue that needs to be improved on, and we're going to talk about that. My opinion is that these products actually have little to no differentiation. You know, despite what the issuers might argue, there's very little that differentiates them. It's like, oh, you can trust me a little bit more, or you know, my licensing regime is different. Like, that's not really a different. Like, these products are effectively commoditized, very similar in nature. If you consider like the technical layer that they have, it's very simple and very much the same. They do have strong network effects, though. They behave a lot like payment rails from that perspective. So in the sense that, you know, if I'm using PayPal and I have the power to tell somebody to pay me using that payment rail, that has strong network effects because it kind of connects this network that uses the same payment rail together. And it's very interesting from a business model point of view because these issuers in these models, they don't really generate any utility. Utility from the point of view of, and maybe I'm being too rough, don't generate any utility. They generate some residual utility, but the majority of the utility is generated by use case venues. So a centralized crypto exchange, for example, a DeFi protocol, this is where the utility is for those products. But the issuers sit outside of those utilities, and they keep basically 100% of the upside, whilst the use case venue is generating all of the value really in the sense that it is accumulating all of the customer deposits, but it's keeping none of the upside. And despite some reasonably high barriers for entry from the perspective of what it takes to build one of these centralized issuers, but also what it takes to break into the network effects, there are a lot of new entrants coming. So if we have about 22 live products today, we're going to have a lot more in the coming months because there's a lot of companies coming to market. And we think that's a reflection of the famous quote by Jeff Bezos, you know, your margin is my opportunity. The business for decentralized issuers is too juicy for you not to see competition in the near future. Let's think critically about this market and its structure. When you zoom it out a bit and ignore crypto versus traditional finance, and think about structures that have been in place a lot longer, so before blockchain, before crypto. What lessons can we learn from that? I think the first one is that tokenization is not necessarily a new thing, right? If you assume that e-money issuance is also some form of tokenization, is also taking a form of money from a counterparty and issue an electronic instrument on top of that. In a way, that is tokenization, that has existed for many, many decades around the world in different ways. Obviously, issuing these instruments on a blockchain is kind of the novel element, but is not as innovative as some people claim to be, particularly in the way that these products have been architected. The other thing that we can think about is what are the equivalent to these stablecoin issuers in traditional markets? So what is a Circle? What is a Tether in traditional markets? Are those e-money issuers? So is PayPal an equivalent? Is Square Cash an equivalent? Is Starbucks an equivalent? I mean, Starbucks, if they're dollar balance product that I'm sure most of you use to buy a cup of coffee, if that was issuing an electronic instrument that was available on a blockchain and people decided to call that a stablecoin, it would probably be the fourth or the third largest stablecoin comparably. So are those equivalent to stablecoin issuers? Are banks equivalent to stablecoin issuers? Are what banks do in the form of issuing deposits equivalent to what these stablecoin issuers are doing? Are payment rails equivalent, right? So is an ACH, is a SWIFT and Fedwire equivalent to stablecoin issuers? I think the answer is not really yes and not really no for any of these. Stablecoin issuers are kind of a novel thing that was invented, but also a little bit of a weird animal because it is novel. And I think what we will talk about later is that the market is evolving for that novelty to go away and for us to go back into more traditional business models. Because if you think about it, what is the typical business model of these traditional constructs and what is the technology stack of these traditional constructs? It's a lot more sophisticated, a lot more complicated, and a lot more valuable than what stablecoin issuers as they are today are. So let's talk a little bit more about interoperability in particular then. This is not, obviously we don't have time to do a lot of history discussion here, but historically, for a couple of hundreds of years already, we have grown accustomed to, despite some people, especially on policy and regulatory elements, enjoying that or not, but the vast majority of the money that we use today is issued privately, right? It's called private money. Cash, for example, which is something that is issued directly by governments, is actually a very small part of what we use on a day-to-day basis. I mean, the money that you have on your bank accounts, the money that you have on digital wallet products, those are all issued privately. And the way that this started, particularly if you want to think about the U.S., is in the form of commercial banks, the narrow banks, the cowboys of the time, issuing their own instruments to behave like money, so the early IOUs, and issuing those deposits in a way that was somewhat structured and over time somewhat similar. But it was highly fragmented. So you have all these banks, they're issuing their own private version of money. They're not interoperable, right? So if you're dealing with a bank in Arkansas versus a bank in Texas, like they are completely different and they don't interoperate. You're going to have to trade effectively one instrument for another. And obviously, as the economies around the world evolved, like this proved to be an extremely limited model, right? It's obviously bad for you to have a very fragmented version of money in a society. It's going to be on the way of economic growth and activity growth. So eventually, if you want to consider that a technology stack, it has evolved around the issuance of private money to include things like central banking, to include things like clearing houses, and et cetera. And so all of a sudden, there was a lot more standards around it. There was a lot more sophistication around how these instruments should be issued, how they should be governed, and how they should interoperate. And if you think then, today, the way the banking system works, most of the time around the world, you continue to have all these versions of private money being issued. I mean, effectively, when you have money at JP Morgan Chase, it is not the same money that you have if you have a deposit on Bank of America, right? And a good example to illustrate that is about a year ago, if you had dollars on Silicon Valley Bank, were those dollars effectively the same as dollars that you had on Wells Fargo? No, they were not the same because they were about to disappear for a while, right? So, so privately issued money still exists today. The difference is that we just have better technology stack, I would argue, in traditional markets than what we have in stablecoin markets today. In terms of governance, in terms of ensuring interoperability, the technology stack is more robust and is more sophisticated. And the reason why we're talking about this is effectively to illustrate that we need to go through that exercise in history in stablecoin, in the stablecoin sector as well. Because if we think about stablecoin interoperability for a second, these products are definitely not interoperable. This is an argument that I have sometimes with people, and people say, no, but I can trade, between USDC and USDT. Yeah, but trading is not really interoperability, right? I mean, if I send you an email from my Gmail account to your Yahoo account, and you lose like a couple of characters at the end, in like as title of, the cost of interoperability, is that really interoperability? No, there's no standard. There's maybe an underlying standard in things like the blockchain asset standards like ERC20, but there's no standard at the stablecoin level. And users have to really go through a price discovery exercise to convert from one form of these guys to another form. So if I have USDT and I want to get to USDC on the other side, I effectively have to trade one for the other. And that involves price discovery, involves going to a market, and involves somebody assigning, ascribing value and price to my assets. And if you want to create a new stablecoin issuer, like it just has a lot of barriers for entry, at least in the way that people have thought about it. Because people have thought about it, okay, I'm just going to copy this model and I'm going to create my stablecoin, and my stablecoin is going to be incrementally better. But for me to have a business, I actually need to gain acceptance and adoption of that. And so people need to recreate all the set of use cases, push for traction, push for trading liquidity. And effectively, this leads to market fragmentation. Like what I'm advocating is that people got to stop doing that. Like, please stop issuing new stable coins if they're completely fragmented and not interoperable. First of all, you're unlikely to win because the difficulty of breaking into the network effects of something like USDC and never mind Tether is enormous. But most importantly, because you don't have to do that. Why do you have to care about use cases all around the world? I'm going to propose a different strategy here. And obviously, everything that leads to market fragmentation is going to be objected by market participants. Market fragmentation is essentially bad in most of the time, and the counterforce to that effectively is market concentration. So it's what I said. Effectively, we have 22 live products, but in a sense, the top 2 products have 96% of market share. And just for you guys to think about a quick case study here, what Binance did with BUSD in 2022 and 2023 is actually really, really interesting. And we believe that it is actually the way that the market should evolve. So Binance, if you think about it, had a self-branded dollar product. It was recognizable within its ecosystem of services, right? There was a lot of synergies. For example, you got free trading on Binance if you used BUSD as opposed to some other product. They implemented over time this seamless auto conversion process, right? So if I deposited Tether, I would have a dollar balance on Binance, and behind the scenes, they would actually auto convert that Tether that I deposited into BUSD. Again, moving a little bit away from this idea that stablecoin are retail products that customers actually have a choice and they say, no, I'm going to hold this thing on my wallet and not the other thing because I'd like this color better than the other. That is a false prerogative. The reality is that you're going to use services, and whatever that service tells you to do, you're going to do it. And so it is the prerogative of a service like Binance to completely auto-convert all of these deposits into whatever form of dollar is better for them, which in their case was BUSD, because they would make the treasury yield on top of 100% of the customer deposits, which is precisely what a rational company should optimize for, right? They own the business model, and they didn't need to push adoption into other venues. So think about it. BUSD was completely irrelevant outside of Binance. Nobody cared about BUSD outside of Binance. Probably nobody cared about BUSD, period, unless they were using Binance services. And again, why should it be different? Why should Chase go to Bank of America knocking on the door and saying, you should definitely use my dollar infrastructure? Like, it doesn't make any sense. These venues should be completely independent. So let's talk about what we do at M0 then. What is M0? M0 is, and I should say it will be, because it's in the process of launching in a couple of months, but it will be an on-chain protocol combined with a set of off-chain standards and APIs that effectively allows multiple institutions to issue a fungible crypto dollar. In our case, we call it M. So effectively is turning the infrastructure of stablecoins upside down and acknowledging a certain belief system. So this is what we believe in, that money issuance infrastructure should be democratized. So if you think about it, there's no way today for me to knock on Tether's door, to knock on Circle's door and say, I would like to issue your product as well, can I? There's no, first of all, they're going to tell you no, but second of all, there's no construct for that. While it's in traditional markets, is there a way for me to become a new bank? Hell yeah, it's pretty well understood. Is there a way for me to become a new e-money issuer? Hell yeah, very well understood, very large markets. So it's not tenable, it's not practical, particularly in crypto and blockchain as an industry where the ethos is so different, for us to say that, there should be these ivory tower, dollar product issuers, and nobody should touch them. That's wrong, and we think this infrastructure should be democratized and available for any institution. The other thing is every use case venue should become their own issuer. That's something that we believe in. Every centralized exchange that has digital dollar customer deposits, pardon the word, but they're stupid if they're not issuing their own stablecoin. They're losing money. They're hemorrhaging money every day to these large issuers, and there's no reason why they shouldn't issue their own stablecoin. The problem is that people have understood this in the past in the wrong way. They think about it as, oh, I'm going to have to issue my stablecoin and then spend a lot of time and money going around and gaining adoption. And our answer is no, you don't need to do that. Just focus on your own business. Do you have a small exchange that has $200 million in customer deposits worth of stablecoin? Create your own stablecoin and auto-convert all of that into your own and make 5% on top of that. The other belief that we have is that reserve and collateral quality should be standard, should be pristine. Obviously, this is the most important thing for these products, but it should be standard. Enough of this thing of, my money market fund is better than your treasuries, and your partner for holding treasuries is worse than this other one that I got, and your jurisdiction is worse than mine. This is all like childish. This securitization, proper custody of collateral has been done for decades. And I think in crypto, sometimes we have to relearn what has been done for decades in traditional markets. There's no reason to innovate in this. You just find a standard securitization, like orphan, special purpose vehicle in some very, very sound jurisdictions. You collateralize a stablecoin with US Treasuries, short term probably, and off you go. You don't need to argue with anybody that that's good or not, because that has been proven to be good for years and years and years. The other belief system is that interoperability should be an ecosystem-wide goal. I'm very disappointed that we as a stablecoin ecosystem are not rowing behind and arguing more about this. I think people say, oh, look, it's the killer use case in crypto. Look at how much traction we have gotten with dollar stablecoins, and that is true. But we have landed on a very, very bad spot today. We have landed on a spot where a single issuer has 75% of the market. There's no interoperability with anything else. Just think again, zoom out and think about traditional markets. Would we be okay in any jurisdiction with a bank that holds 75% of customer deposits in that jurisdiction? No, that's an extremely bad from a concentration risk. Regulators would intervene much earlier than that, and we got to think about that. The lack of interoperability is really bad for consumers and for all the venues that utilize these products. And effectively, we have put these products, as czars, as dictators in an ecosystem that, from an ethos point of view, should be a lot more decentralized and open. And the other belief that we have is that the business model for stablecoin issuers, in the absence of utility services, will come to an end. So somebody who is just a stablecoin issuer, period, and they don't do anything else, they don't create any utility for that product, that's going to come to an end pretty quickly, we believe. So very quickly, the way that M0 works is that it outlines a couple of specific actors that participate in a coordination system. There is eligible collateral that, from a governance point of view, there's criteria dictating what is eligible collateral. And imagine, in this case, short-term U.S. Treasuries to begin with, that gets allocated and custodied in collateral storage mechanisms that, again, are very, very pristine, but very standard. No, not a lot of innovation there. But they are separate from the issuer. So imagine that more similar to banks, this collateral is actually injected almost like equity from third-party providers. It's not the deposits that's coming from customers. You have issuers. You have an external type of entity called a validator that verifies that this collateral is in place and emits proof of reserves on chain. And then that issuance, of the stablecoin gets sent into the market and gets traded into the market. So this is effectively how it works. We are very interested in discussing with folks that are interested in becoming validators, issuers, supporting collateral storage. We're open for business and interested in discussing with folks who are passionate about stablecoins. You can find some contact details, and thanks for the time.
Alrighty. Thanks, y'all, for being here. This is a talk called Turning Assets into Agents with ERC 6551. We're going to talk a little bit about what assets are, what agents are, why they're important, and how ERC 6551 interacts with that. So I'm Jaden. I'm the CTO at Future Primitive, where we've been building ERC 6551 and tooling on top of it for the better part of a year. One of the co-authors of the standard, and I've spent basically all my time working on this for the last little while. So excited to share what we've been working on. Now, how many of you own one of these or owned one of these in the past? Any hands? Yeah, okay, a few, right? This is a feature phone. They were great. You know, you could make calls, you could do texts, you could they had some features that the manufacturer included. You could play Snake, you know, you might have a calculator or a calendar. They're kind of like a landline, but better. You could bring it with you. How many of you have one of these in your pocket right now, a feature phone? Anyone? No, I didn't think so. You probably have something like this in your pocket. You have a smartphone in your pocket. And smartphones were just infinitely better than feature phones. They brought a bunch of new features that really just changed how we interact with the world around us. You got internet access, so you weren't just limited by calling and texting your friends and family. You could interact with all of the information out there on the internet. And instead of just being left with the features that the manufacturer created for you, you now had this whole ecosystem of third-party apps. Anybody who had an idea could build it for your device. We just saw this proliferation of what you could do with a smartphone. And it was a whole new way of interacting, right? It wasn't just buttons on a keypad. It was taps and swipes and pinch and zoom, a new way of interacting with the device that just brought a whole new way of using it. It was just fundamentally better. Now, if feature phones were the past and smartphones are the present, what might be coming next? What's the next big leap in interacting with the internet or interacting with the world around us? I think we're starting to see some really interesting signs. I don't know if any of you have played with any of these. This is the Humane AI pin, the Rabbit R1 device, AI device, and ChatGPT's voice interface. These are really cool. You can just talk to or interact with these devices, and they're kind of like agents. They do things on their own. You ask ChatGPT something, it just tells you. It doesn't make you go click a button to do something. It gives you the information you need. You tell the Humane pin to take a photo, and it just does. You tell Rabbit to book you flights, and it just does all on its own. And they adapt to their environment, right? It's not programming individual button clicks and presses. It's, you know, it will go and find the site and book the flights for you. And you're not interacting with taps and swipes anymore. You're interacting at the level of voice and ideas. It's a new way of interacting with devices, a new way of interacting with the world around us. And you can see kind of the tech tree progression here, right? You start with an object that has some utility. It just generally makes life better. It's more convenient than what we had before. And then you add programmability. You let people build applications for it. And you just have this Cambrian explosion of what you can do with it. And then you let it start doing things on its own. You give it agency so that it can take actions for you. This is kind of the natural progression of things over time. Now, what does any of this have to do with NFTs? We're at a crypto conference. We're talking about NFT standards. At the base level, NFTs are internet native objects. They're just like the objects we interact with in the world around us every day. And you know, they're great. You can own them, you can transfer them. Those are the two things that are standardized in ERC 721. They might have some utility that the creator of the NFT has defined for you. For example, CryptoKitties, you could breed them. That's super cool. And it's just better than a database. It's better than your data being in, you know, Facebook's database. You own it with your own private keys. It's an object you own. But NFTs are kind of in their feature phone era. You're still locked into the utility that a creator provides you. There's not many applications beyond that. And what about programmability? What about the ability to extend an NFT with new ways of doing things? What about agency? What about the ability to act on its own or interact with the world on its own? We don't really have that. And you know, it was never part of the standard or the original design of NFTs. And about a year ago, we've spent our whole company's lifetime building crazy experimental NFT applications. And we realized that there's a really neat way you can enable both programmability and agency for NFTs. Last year at ETH-Denver, we launched ERC 6551, and we introduced the world to the concept of a token-bound account. This means that every NFT has its very own wallet. And that goes for existing NFTs like CryptoKitties and the NFT collection that launches tomorrow. As soon as an NFT exists, it comes with a unique wallet, a unique identity. This means every NFT can own assets. ETH, ERC20s, 1155s, anything that can be owned by an Ethereum wallet, your NFT can own too. It also means your NFT can execute transactions. Any dApp or protocol that you as a user interact with, your NFT can now interact with as well. This allows your NFT to create its own history, its own identity, its own agency. It can act as its own being. Now, for the technical folks in the house, this is how it works under the hood. ERC 6551 defines a registry contract. This contract is unowned, it's non-upgradable, and it's deployed to the same address on every Ethereum chain. This registry reserves address space for NFTs. It ensures that every single NFT has a unique address assigned to it, and anyone can create the smart contract at that address by calling into the registry, providing some information including the chain ID, address, and token ID of the NFT. This means that every NFT inherits those capabilities. And how does it bind an account to an NFT? It actually embeds that data into the bytecode so that permanently on the blockchain, the nature of that account has the NFT data in it. This means that any application your account interacts with knows it's a TBA interacting with it, and it knows which NFT is taking the actions. This opens up a bunch of possibilities for you to build really cool applications with NFTs. And we spent the past year or so working on developer tooling and UIs and just things to make it easier to build with 6551. You don't have to worry about bytecode structures. You can just work with a really nice SDK and a really nice UI. Now, let me do a quick demo of how this works. If you go to tokenbound.org, you can play with your tokenbound accounts for your NFT. So this is an NFT I own. Let's see if I can get the demo to work here. There we go. This is an NFT I own, and this is its token-bound account address. If I go to OpenSea, I can paste in that address, and I can see the contents of this Ethereum wallet. Now, OpenSea has no idea this is an NFT. It just knows this is an Ethereum wallet, and it owns some assets. So it just works with anything on Ethereum that works with accounts, which is pretty much anything. But because it's a wallet, I can connect to OpenSea as my NFT and execute any action on OpenSea. So I just went to Wallet Connect, and you'll see it'll prompt me to sign with the holder wallet of that NFT. So I sign on behalf of my NFT, and now I'm using OpenSea as an NFT. You can see that I can go and I can list this NFT, right? Any action I can take in the dApp, I can now take as my NFT. So I can go and I can list it for sale, I put in all the details, and it'll prompt me to do this transaction. This is really cool. This means NFTs can just participate in Ethereum like everybody else can. Same with something like Uniswap. If I take my tokenbound account and I go to Uniswap, I can connect my wallet, and this will let me swap Ethereum that is stored in my tokenbound account, just the same as I would if I was a normal Ethereum user. Tokenbound accounts are a medium for turning NFTs into Ethereum users, into agents. And this enables tons of possibilities for developers who want to let NFTs do more things. It also opens up a ton of possibilities for you as an NFT owner. There's no code here, right? You're just doing normal Ethereum transactions, but you're doing it as your NFT. If you're a developer and you want to start working with this, we have an SDK. It's just as simple as pulling in VM or WAGMeet or anything else. It's one call to get the tokenbound account of an NFT. It's another to execute transactions from it, just the same way you're used to if you were interacting with a wallet. Now, there's still some unsolved problems with this. If we go back to the feature phone example, when I want to go from the US to Canada, I can just bring my phone with me. It just works, right? I might have to pay some data for roaming. I might have to get a calling card or a SIM card. But by and large, I just bring my phone with me. It's not quite the same for NFTs. NFTs are by nature single-chain assets. They live on one Ethereum chain. So if I want to bring it to another chain with me or do something with my NFT on another chain, I have to interact with the bridge, which costs gas money. I have to worry about finality and bridge risk. It messes with the provenance of the NFT because it's not just as simple as me bringing my NFT with me. If I'm going to bridge an NFT, if the NFT has native integrations with a bridge, which is usually only newer NFTs, I can burn the NFT and mint a clone on the chain I want to use. So I would burn the NFT on mainnet, mint a clone of the NFT on Polygon, and then go about my business, use my NFT. And if I wanted to bring it back, I would get the NFT reminted back to me. But what about all of those NFTs that predate bridge integrations? In that case, you're putting your very valuable asset into a bridge contract with everybody else's NFT. If that bridge ever gets hacked, your asset is gone. And then you're minting a clone on the layer 2 chain. As you get into the situation where you're tracking which clone is the real one, where does the NFT actually live if it's not on the origin chain? Because the origin NFT still exists, but now you've got a clone. If you bridge it 2 or 3 times, it's hard to keep track of where it is. What if instead of moving your NFT from chain to chain, your NFT just had an identity that lived across every chain at the same time? What if your NFT was just like a wallet? where you can use your MetaMask wallet on any chain you want to. What if your NFT was the same? That's what we've done with token-bound accounts. If I own a noun on Ethereum and I have the token-bound account 0x123, that same token-bound account exists on any Ethereum chain at the same address, and I can use it just like a normal wallet. So if I want to play a game on Polygon or trade meme coins on Base, my NFT can own those tokens on Base without the NFT ever having to change chains. If I wanted to own a lens handle on Polygon, same thing. All the dApps you integrate with as a wallet, you can use as your NFT. Now, we launched this about a year ago. We've been working really steadily on improving bridge support. And right now, we have support for Ethereum to Polygon and Ethereum to OP-Stack chains, which is nice. But in a lot of cases, you actually want to go from destination chains from layer 2s like Polygon back to Ethereum. And we don't support that right now. But really excited to announce that we're partnering with layer 0 to make token-bound accounts work on any chain supported by layer 0 by default. This means that your NFT on Ethereum can just use any chain it wants to. Anytime you use the token-bound site or the token-bound SDK, all you're doing is specifying which chain you want to execute the transaction on, and all the details about how that works happen under the hood. So if you're a user, you don't have to worry about interacting with the bridges or which chain does my NFT exist on. You just worry about doing things as your NFT. So if I want to do a transaction on Ethereum, on Linea, my token-bound account would call from Ethereum to Linea, and then the receiving contract on Linea will know that it comes from 0x123, my token-bound account. The receiving contract on Linea knows which NFT is calling into it and knows that whoever initiated that call must own the NFT. This also works for destination chains. So Polygon can execute transactions on Blast, or if you wanted to go from any other chain to any other chain, your NFT, no matter which chain it lives on, can execute actions on any other chain. Now, this is going to be live in the next little bit in March. If you're at the hackathon and want to play around with this, please come see me. We'd love to get you hooked up with it. We're going to do an announcement in the next couple of days about this specifically and some docs for it. There's still a couple of things that are missing here, though. We're still maintaining a list of trusted bridges, which is not great. We want to get this fully decentralized. Right now, we're whitelisting bridges one at a time. It also means that every time you want to do a transaction, you get a transaction pop-up. You have to click that sign transaction or submit transaction button. And it also means it only supports NFTs, right? This kind of part of token-bound accounts so far is it's NFT native. Your NFT has an account. But what if we want to move beyond those limitations? We're working on V4 of the token-bound protocol right now, and there's a couple of really key improvements. The first is we're going to be integrating layer 0 natively into the token-bound account. This means no more centralized whitelist of bridges that we manage. This means you, as the NFT owner, get to bring your own bridge. You get to choose your security model, choose the way you want messages ferried from your origin chain of your NFT to destination chains. This means that it's fully decentralized. You don't have to rely on us to maintain this. You, as the NFT owner, have full control over it. If you picture the idea that I was saying before of agents, right, of interacting with things like Humane or the Rabbit R1, you just kind of ask it to do something, and it does it. And TBAs right now aren't really like that. If I went to my TBA and said, hey, can you collect the most popular Zora NFTs from this week, my NFT has no idea how to interpret that, right? It just knows how to interpret transaction called in. And even if it did know how to interpret it, it would still ask me to sign a bunch of messages. I would get a bunch of pop-ups. Every time it wants to do an on-chain transaction, I get a transaction pop-up, and I have to sign it. It requires the owners to approve it. It requires a human in the loop. And if we're going to move into this future where it's just agents, where I'm just saying what I want to do and it happens, it's really difficult if I have to manually approve everything. It's kind of the equivalent of a button click on a smartphone. How do we move from this to a model that's more agent-like, where I just say, I want this thing to happen, and it happens? This is going to be a pretty big difference between token-bound v3 and v4. It's a kind of a giant step. We're introducing this concept of an auth extension. It's a way for NFT owners and NFT creators to change how the token-bound account interprets who can use it and where it can be used. So instead of the owner having to always manually sign a transaction to say, hey, go and mint me this thing, the NFT owner can delegate an auth extension and say, hey, I'm going to delegate an auth extension that knows how to interpret my random requests for Zora mints and is able to execute those on chain without prompting me for a signature every time. And this kind of removes the human in the loop. It's kind of like power of attorney. It's giving access to your token-bound account to a new contract. Now, this is tied to the owner, right? If I'm the owner and I set an auth extension, and then I transfer the NFT to someone else, it's a blank slate for them. But as long as I own the NFT, I have full control over the auth extensions. And if I'm an NFT creator, I want to build a really cool game where I don't want transactions popping up every 10 seconds. I can set an auth extension in an auth extension registry that works across chains and say that, hey, for all of the NFTs in this collection, you're going to be able, our game is going to be able to interact with those TBAs. It's going to be able to manage them on behalf of the user in the game. By minting this NFT, you trust us, the NFT owner, to give this game to you. And so our game logic can automatically execute things on a token-bound account. Now, this means that you don't have to sign transactions every time. You can just tell your NFT to do things, or just interact with that dApp, or interact with that game. And things just happen, but it's your NFT doing the actions, your NFT acting as an agent, which is just really different from how we interact with NFTs today. Now, of course, it's all self-custodial, so if you, the owner of the NFT, don't trust the NFT creator, which is kind of a common thing, you can say, OK, I don't want to trust any of the NFT creator auth extensions. I just want to manage it self-custodially. That's totally fine. So that's what's coming in token-bound v4. We're introducing the concept of auth extensions that lets you extend token-bound account authentication beyond just signing a transaction every time. It lets both the NFT owner and the NFT creator define custom logic that determines who can use the token-bound accounts. And it's got native bridging built in, so you don't have to rely on us to maintain a whitelist of bridges. You can just choose your security model and choose how you want these transactions to go from chain to chain, all while maintaining the token-bound account, the singular identity that exists for your NFT on every chain, and maintaining the ease of use and the ease of programmability of this paradigm. Now, there's one more thing that's really cool with auth extensions. Right now, token-bound accounts are ERC 721 only. So it's an NFT that's non-fungible. There's only one copy. And if it's a non-fungible token, it has a token-bound account automatically, and you can use it. But one of the things we've gotten a lot of requests for is, like, what about ERC 1155s? Those are NFTs, right? Kind of. They're semi-fungible, but they can be non-fungible. What about my custom token type that I developed just for my game that I really want to use? What about this new token standard that launched last week that's not ERC 721? Auth extensions provide a solution to that problem and allow token-bound accounts to represent any asset on-chain using the same approach of giving a unique identity to an asset that's capable of owning assets and taking transactions. This means that you can write auth extensions to support ERC20-bound token-bound accounts, or ERC6909-bound token-bound accounts, or game-bound token-bound accounts. Anything you can identify with a chain ID, contract address, and token ID, you can tie to an account. Now, this goes a little bit beyond the ERC 6551 standard, but there's some really cool possibilities here, especially if you're doing kind of novel things with NFTs. So if you look at it over the course of where we've been in NFTs and where we're going, NFTs started as an asset, as an object you own. Self-custodial, you can own it, you can trade it. That was really great. It solved the objects being stored in centralized databases. It gives you an object you own and you control yourself. And that led to a lot of really cool applications, right? Token gating is a great example. Because you own an asset, you can token gate a community or token gate access to something. So you can build some applications on top of NFTs, but you're still pretty limited. With token-bound accounts, and specifically with token-bound accounts that are cross-chain enabled and that have auth extensions, we've solved a couple of more problems. We've solved the problem of NFT identity across chains, an NFT identity that just works like you expect a wallet to work. We've also solved the problem of utility. The entirety of the Ethereum ecosystem is now the utility of your NFT. You can do whatever you want, just like you as a user can do anything you want in the Ethereum ecosystem. Nobody has to build anything for token-bound accounts or ERC 6551. It just works out of the box because everything in Ethereum supports accounts. And then if we look forward to NFTs as agents, to going from just objects with utility to objects that are programmable to objects that can act on their own, with auth extensions, we have the ability to let NFTs do things themselves, to let NFTs really be this representation of a unique identity on-chain that can take its own actions and do anything it wants to, even though it's still owned by a user. And the amount of ways that that can be integrated into our experiences on-chain, applications on-chain, how we interact with the Ethereum ecosystem are hopefully as limitless as the smartphone was compared to the feature phone. You can do anything you want to with an NFT now, and it's really easy to integrate with. So that's a quick history of what we've been building with 6551, what we've been building with token-bound accounts, and what's coming down the pipe. If you are interested in chatting about any of this, or building with any of the tools, or working on 6551 at the hackathon, our team is all in these blue jackets. You can come find us. We'd be happy to help you integrate with it. And we're really excited for this. We're really excited to partner with Layer 0 to bring NFT token-bound accounts across chain. And we're really excited for all the changes coming forth in the future. So I have to leave you with one thing. I think agents are the future. I think this experience of interacting with agents is going to be really cool. And hopefully token bound accounts can help with that. Thanks, y'all, for coming.
The next event at this stage will start at 2:45. Thank you. Francesco with Superfluid. Please report to the Neptune stage. Your presentation starts at 2:45. Francesco with Superfluid. Please get over to the Neptune stage.
1, 2, 3, 4. OK, this works. Awesome. So thanks, everybody, for coming here. Today, we are going to talk how to build the cross-chain yield DEX on Starknet in this case. So brace with me. There will be some technical stuff, but I will try to be as gentle as possible with these kind of things and make it as simple as possible. So a bit about me. I started as a core dev back in the day, basically worked on something that's called Socrates, which is a toolbox for ZK and Starknet on Ethereum. These were like the old days, when the ZK was starting. Then I moved to Solidity team, worked there for 2.5 years on Sourcify, founded a company afterwards called Shard Labs that did basically a bunch of like LSD stuff, DeFi related and so on. And most recently, basically been building like tooling and infra on the Starknet. And out of that came Nimbora, which will be the topic today. So let's talk about how Web2 works. We all know when we go to some website to use some service, well, what happens is we click and it works. It automatically works. And what happens with Web3 is we go to a website, then we connect with a wallet. Maybe we have to change an RPC because it's the wrong network. Then some stuff break. Stuff is not the best. But when we compare like the user experience, it's much worse in Web3. But still, when we think about it, Web2 is not synchronous. It's asynchronous. We have a lot of requests on servers, different services and stuff working in the background. But for the user, it feels like a synchronous experience. When we think about modular versus monolithic architectures in like general rollups, shards, or whatever, we have two approaches. One is obviously Solana, which is monolithic. So you try to run as big hardware as possible with optimizing everything and stuff like that. And that can scale to a point. There are like some limitations like speed of light for propagating information and how much hardware can process. And we have the other approach, which is more Ethereum approach, which is this kind of main chain, which is Ethereum mainnet, and these rollups basically, which is kind of co-processors of Ethereum that are scaling it. What's the disadvantage with the second approach is you have broken composability. Basically, liquidity is sharded or broken across multiple chains. User experience is broken across multiple chains and so on. So what's the solution? It's quite simple, actually. We build synchronous user experience for the end user in a synchronous world. Some call it chain abstraction. It's kind of magic. It sounds easy and so on. Well, is it? Let's deep dive. How do we do it? So I want to first introduce you like Deborah the penguin, guardian of the seamless interactions. It's the idea that users should not be explained all the complexities, how the blockchains work, what wallets are, all the things basically we are trying to push on them, but we should make it simple. It should be kind of one-click experience like you have in Web2. Who here used one-click checkout in Web2 anytime? Like you go to a website, you click on a link, and basically you just check out. So you know how it feels. It's like you just click and that's the magic. In Web3, you click a button, then you wait for a transaction. Maybe you get reorg or this and that. But we have to abstract that if you want to do this. So what Nimbora actually is capital efficient L1, L2 cross-protocol interactions. So imagine a protocol on mainnet that can have user deposits, redeems, and external kind of execution on L2s. So this way, you can kind of give them the same experience of DeFi on L1 while they interact on L2. It's kind of what's the purpose of rollups, isn't it? The other basic one is ultra efficient, obviously, cross-chain yield strategies. This is more specific what we can do with this. So imagine you are on Starknet or ZK Sync or Polygon ZK AVM, and you want to stake with Lido or earn some yields on mainnet. How do you do it? You have to bridge from that chain to mainnet, wait 6 to 8 hours for the bridge to finalize. Then you have to go to the protocol, stake with it, pay $40 in gas if you're lucky, and then you get the assets and maybe bridge back. Well, what if we could automate all of this and do it with your friends? Because if the cost on mainnet is $40, and let's say we have 5 people, 5 friends, or 5 users that want to use this in, let's say, a time frame of 24 hours, well, we can do $40, divide them by 5, and everybody pays basically just partial of the fee. And this way, we improve the user experience. And this kind of is called DeFi pooling. So why we went with Starknet first is because it's powered by native account abstraction. That means that you don't have any EOAs there and so on. The issue with EOAs, obviously, is it's kind of a pseudo permission in Linux. So you basically can do anything with it and so on. And with account abstraction, it's kind of smart accounts. It's more granular. You can do whatever with it, and you protect the users from using sudo all the time. And this way, what we did is, user comes to StarkNet, ZK Sync, or some other L2, deposits assets from their wallet, which is account abstraction based, which can feel like Web 2. They don't need to pay the gas fees because you can use Paymaster. They don't need to know when this will get executed to L1 and so on. They only need to know their local kind of thing. It's one click for them. So even if they don't have the assets that they want to deposit and earn from, you can swap for them in the background and so on. And obviously that's called one-click DeFi. Swap, deposit, earn, all in one click, and you can chain as much as you want. How does it actually work? Well, there is a bit of stuff going on in the background. So let's go through it quickly. So as we can see, these are a couple of strategies. We have L2 part, and then we have at the bottom we have L1 part. L1 part is just like simple strategies like stake with Lido, like deposit DAI into Spark to earn SDAI, or do like delta neutral leverage or something like that. Then we have obviously like the bridge in between, which in this case, in case of StarkNet, is StarkNet canonical bridge. We only use canonical bridges because the security of the rollup depends on the security of the bridge and vice versa. Basically, the rollup is as secure as a bridge. That basically is canonical on it. And basically, we use native messaging to transfer messages from L1 to L2 and back. And then on L2, we have this vault-based system where we aggregate user deposits and redeems. So let's say there are a couple of us that want to stake with Lido. I have 1 ETH, I put it in the vault. You have like 2 ETH, the other guy has 3 ETH. So basically all that combined is 6 ETH. And somebody wants to kind of get back his 3 ETH because he earned enough, it's bull market, ETH went to moon, so he doesn't care anymore. Well, the only thing we need to do is we match that 6 ETH to 3. So we have 6 plus ETH minus 3 ETH. So we have only delta of plus 3 ETH. Now we have to bridge shuttle to L1, deposit with Lido, and get rep test ETH back. And this can scale with any transaction. We managed to do this so you can add new strategies, new options in 60 lines of code in Solidity, which will be decreased even less in the future. But if this is not clear to you because it's too complex, don't worry, Board of the Penguin is here. So for the user, it's quite simple. When we look from the user perspective, what the user has to know. What is the user intent? User wants to come to the platform, he has some assets, and he wants to earn money on top. In this case, user wants to be exposed to rep test ETH, basically Lido staking. And let's say the user doesn't have ETH because that's what you need to deposit. Well, we can swap, let's say he's a Wi-Fi, basically maxi. We can swap Wi-Fi to ETH and then deposit into Vault ETH, and he gets the LP token so he can start earning immediately the fees on top. And for the user, it's one click. He doesn't have to do approve and then deposit or swap first. So basically, he would need to do 4 transactions, usually, and now he can do only 1. And that's kind of a magic of this, multi-calls and one-click DeFi and so on. And for withdrawals, it's basically the same. But the key caveat here is when you bridge to L1, it takes 6 to 8 hours on StarkNet. It takes 30 minutes on Polygon. It takes like 24 hours of ZK Sync. When you bridge from L1 to L2, any of this, it's kind of a matter of minutes. So how do we kind of say to the user, OK, we can give you instant kind of these deposits back, but you have to pay more. You can do that through liquidity bridges or swapping locally. But if you are not in a rush, you can do it normally. So normal mode operations when you want to withdraw from the protocol is maximum every 24 hours, usually less. And when you want to do it instantly because, I don't know, you want to take this money, do something with it, you can do it in a matter of minutes. So this way, we have best of both worlds. On one side, we have like DeFi pooling, which decreases the cost per user, so users are not exposed to L1 kind of gas fees and everything. And on the other hand, you have like a normal cross-chain Zap, which gives you the instant experience as fast as possible, but obviously for a fee. So what's next for us? Well, the idea is quite simple, but quite magic. Any chain, any wallet, any assets, it has to be seamless and one-click integrations. Is it DeFi protocols? Is it buying NFTs on other chains? Is it something else? It has to be simple as that. We can scale, obviously, any L1 strategy and yields to L2s and vice versa. So potentially, if you're on, like, let's say, StarkNet, you can earn Arbitrum yields. If you are on Arbitrum or Optimism, you can earn StarkNet yields and vice versa, or even L1 yields. And then the most interesting part, in my opinion, is we can build novel protocols that have part of a logic and execution on L1 and part of L2s. And this way, you kind of can get the best of both worlds. L1 liquidity, composability, and so on, and then cheaper transactions at the scale of L2s. And obviously, we have an SDK for developers, so they can use this L1, L2, all the asynchronicity basically abstracted from them. So with real layers and vaults, it's kind of integrated, and you don't need to think about it. We actually ran a hackathon, and there were like 4 different strategies built on top easily, like in a matter of a week, which kind of proves this kind of is feasible. It's really interesting to the users. So this was a short intro on this. So if you're interested, join our Discord, and I'm open for questions if you have some. Thank you.
All right, how is everyone doing? My name's Chris Smith. I'm going to be talking about invariant fuzz testing, how you can use the power of chaos to better secure your smart contracts and your protocols. This is going to be a bit of a technical talk. We'll be going through some code, and it's primarily targeted for people who are responsible for ensuring the security and correctness of smart contract code and protocols. A little bit about who I am. Currently, I'm an independent security researcher and consultant doing traditional audits, invariant security engineering and reviews, and protocol engineering. Previously, I was a protocol engineer with pre-in-game MakerDAO core unit and worked as a smart contract engineer for the launch of MCD with the Maker Foundation and was with Consensus prior to that. If you want to follow along, my latest tweet has a link to the code and this presentation, or you can see it on GitHub here at I am Chris Smith, and that link at the bottom. All right, so we're going to be talking about invariant fuzz testing. Invariant testing is a tool that you can use to augment your unit testing, your integration testing, and what you're already doing to secure and test your protocol to make sure things are working correctly. It can also be called invariant testing, as I said, forge invariant testing, or stateful fuzz testing. I'll be talking specifically about how to do this within the Foundry Forge tool set. And basically, an invariant is a statement about your code or system that should always be true. Invariant testing checks that those statements are true after running a random series of inputs against a random sequence of calls. So it's the power of kind of unit testing with fuzz testing, but in a stateful way that maintains state between individual test calls. One of the nice things about invariants is that they can be, and probably should be, defined initially in natural language as the rules of the system. You can probably define them from your white paper or your spec before writing any code, and then they can be part of your development and engineering process to build out your code. The randomness that they have, both in the inputs that go into the functions and also in the sequence of calls that are maintained throughout the test run, is one of the really powerful things about invariant testing. It can help simulate the adversarial environment that your code is going to experience in the public blockchain, and in a way that your unit and integration tests might not, because you may not be thinking of 100 different calls that could happen in a random order that don't make sense to you as a developer because you know what should be happening in your system. But invariant testing will allow you to test all of those edge cases. So I thought to show kind of the power of invariant testing, we would run through a code repo. As I said, I used to work on MakerDAO code, so I selected the DAI ERC20 smart contract. I updated it a little bit so it works with 0824, and remove some of the safe math stuff. But this is basically the DAI contract that's live on mainnet now. As far as the tests go, I removed some of the extra ones to be a little bit more on point with this presentation. We're going to be talking about transfers, minting, burning, approvals for this invariant test suite. So for example, this first test here talks about valid transfers to you, or a user can send a balance from one user, from themselves to another user. It has a specific amount, calls transfer on the DAI token, and then it asserts that the correct amount was sent and the balance is changed. But it also tests that the total supply didn't change. So pretty simple, straightforward unit test here for you. As I said, this is testing a very specific sequence of calls. Our fuzz tests, our invariant tests, are going to test against a random input of and random sequence of calls. So let's look at how we can get that suite set up. You'll see we now have this directory here under the test folder. An invariant suite in Forge is going to have 3 parts. You'll have your regression file, your handler file, and your main invariant file. That's going to be what's in charge of running the invariants for you. Regressions are going to be empty initially. Basically, if you run into a problem where one of your invariants is violated, then Forge is going to give you a sequence of calls that will tell you how you got to that violation. And you can use that to create essentially a unit test here with the random inputs that will backtrack and show you how you ended up in that buggy state. And you can run those to recreate the exact sequence of calls and exact inputs. So we'll put that away for now. Your handler is going to wrap around the contract that you're testing. So in this case, we're testing the DAI contract. We have a DAI handler. Right now, it's just an empty contract. But this is basically where we're going to write the functions that will get called in the random sequence by our invariant test suite. So we'll get more into the meat on that one later. For now, setting up the DAI invariant test file. This is the main test file. This is the entry point that Forge is going to use. We need to generate a new DAI contract for our test and a new handler contract for our test. A little bit of MCD work here. We want the DAI handler to be able to mint DAI when it makes calls, so we're giving it permission to do that by calling rely. These are for the Forge test suite to know which contract it's interacting with, what it should be fuzzing, and what selectors it should call. Right now, we don't have any selectors in our handler, so that's going to be empty. And then I put in a very basic invariant here. This is not a very helpful and probably not even a really valid invariant as far as true invariants go. It's just saying that the DAI contract is deployed with 18 decimals. That's hard-coded into the contract, but I wanted something in place here for us to build off of. And so we can look now at how to set up the handler a bit more. Get to the right commit. So we want to go to our handler. Now we're going to start building out our handler a little bit here. As I said, invariant testing is a good way through its randomness, both in the fuzzing inputs and in the sequences, to replicate what's going to happen or what could happen in the live blockchain. From that perspective, we need actors and, in this case, destinations to be our actors in our invariant testing. So we're going to build an array of actors that we can keep track of, and we'll init this contract initially with 10 actors. So there are going to be 10 users that can either make transactions or receive transactions. They're all going to start with 1,000 DAI just for testing purposes. We have two separate arrays here that we're going to be pulling from. One is the actors. That's basically going to become your message senders. And the other are the DSTs, or destinations. We create a separate array for that because I want to add the address 0 into the destinations in case users transfer tokens to address 0 or function calls go to address 0. We want that to be part of our recipient class. But we don't want to be making function calls from address 0, because if a message.sender of address 0 shows up in your protocol, we probably have bigger problems on the chain than something that's happening in your protocol. As I said, your DAI handler is going to be a wrapper around the DAI contract. That's what this function's doing. So we want to test all of the external state mutating functions in DAI. In this case, we're going to start with the transfer function and wrap the DAI transfer call in this handler function, where we're going to use a random actor. As I said, this is going to become your message sender. We'll talk about resetting errors in a second. And then it's a transfer, so we're sending from that sender to someone else. And so we're just pulling another random destination from that array here. This is where you start to see some of the Forge fuzzing come into play. So the inputs for this function are an actor index, a destination index, and a WAD. If you know Taiwanese, WADs are what we use for amounts. That's just the amount of DAI that's getting transferred. The actor index is a random input. All of these are random inputs of type UETH-256. Forge is going to actually plug a semi-random value in. Those values tend towards the edges, so they tend towards 0 or towards max UENT, and get fewer values in between. We'll talk a little bit more about that later and why that's important to keep in mind. But basically, these are our random inputs. We're going to use those to pick random actors with this select destination and use random actor functions. We wrap the actual function call, the die transfer, in a try-catch because we don't want to fail every time the protocol actually reverts. And if you look here, you can see that in some cases, we actually want to catch an error and allow it and allow the suite to keep running. So when you run an invariant suite, you're going to define a number of runs and a depth. And the number of runs is the number of times that the whole suite runs. The depth is, I think, the more interesting number because it defines how many function calls occur within that stateful test. So it's going to maintain state. If you say 100 for your depth, it will maintain state and make 100 random calls from your handler against your protocol and keep track of everything. So we want to make it all the way to 100 unless we hit an unexpected error. In this case, we know that if we're trying to transfer an amount of die that is greater than the user's balance that's doing the transfer, we're going to get this die insufficient balance error. We don't want to stop our test suite if we hit that error. That's expected. That's our code working the right way. So that's all this if die balance of the actor is less than the amount that we're sending, add the expected error. That's what this is doing. Expected error here will check if we hit an expected error, and if we didn't, then we're going to throw a revert. And we will get, and that's when we'll get the sequence from the Forge test suite. And that's kind of what we're looking for with these invariant tests, because then we know that we found a problem in our code. As I mentioned, we have these select actors and select destinations. They're internal functions. They're helper for how the handler works. One interesting thing here is this bound function. This is part of the cheat codes of the Forge test suite. All that's doing is saying, give me the actor index, which was between 0 and max UENT 256, and narrow that range down to between 0 and the length of our actors array, so that we get a valid index here that we can pull from our actors array. We only had 10 actors and 11 destinations, so we don't need max UENT 256 here. Let me go back and type in the proper place. With that initial transfer setup, that makes building out the rest of our external functions. I'm sorry, they're not showing up here. Here we go. The rest of our external functions for the die contract, fairly straightforward, kind of repeating the same pattern. We're selecting random actors, random sources in the case of a transfer from or an approval, and a random amount and a random destination. You can see here we start adding additional errors. So in a transfer from, you need an approval. If you don't have the sufficient approval, we want to catch that error and allow it because we know that you're not supposed to be doing what you're doing. It's not an error in the function. And then the other piece is, I mentioned in our setup that the handler needed authorization. In order to successfully mint, you have to be a permissioned contract on the die contract. If the actor calling the mint function is not permissioned, we expect it to throw a not authorized error here. So like I said, kind of more of the same as far as building out our external functions. Now our handler has seven of the external selectors that we want to be testing here. We add those to our selectors array in the invariance test main file, which is getting passed into the target selectors as a part of the fuzz selector object for Forge. These are now the 7 functions that it's going to call randomly in a random order in our 100 depth stack. So we might get a transfer, transfer from, transfer, mint in those calls, and start simulating kind of the churn and the chaos of the public blockchain. Let's talk about, now that we have our handler built out, we have our test suite functional, but we didn't have a very interesting invariant. We were just testing that die had 18 decimals, which can't change. It's a constant on the contract. A more interesting invariant, and one that should hold true for all ERC20 contracts, is that the sum of all user balances equals the total supply of your token. That is what this invariant now tests. So we grab all of our destination users we sum their balance of, and we check that against the die total supply. The real power of this testing comes into play because this rule gets tested after setup when you run your functions, or when you run your tests, and after every single one of those handler calls. So every time the invariant test suite makes a new handler call to a depth 100 or 1,000 or 10,000, it's going to come through and run this invariant test and make sure that this rule holds true. So it becomes something that can never be wrong or never be changed about your protocol. And if you run your invariant test suite many times over a long period of time, you have enough randomness that gets introduced, that your system gets tested against, you can start to say that this is an absolute rule of your code, that the user balances can never exceed the total supply or never be different than the total supply of your token. And that can be a really, really powerful thing to have alongside your other testing. Let's talk a little bit about the benefits and limitations and how you could take this to the next level with your project. So every approach to security, whether it's unit testing, traditional auditing, integration testing, fork chain testing, they're all going to have limitations. And invariant testing is no different. Some things just don't work well as invariant rules. You need those invariants to be things that are always true, no matter what. You can program some conditionals into it, but you can't really write good invariants if it's only true after this function calls this other function sort of thing. Or if you have things that are happening outside of your smart contract code, like governance actions, or if you're dealing with upgradable smart contracts, then anyone can change the list of actions that your contract can do, the proxy actions that are getting called, and the invariants wouldn't necessarily hold anymore. But as in addition to your current testing suite and to your current security practices with your code, this can be a really powerful thing. As I said, you can look through your white paper, look through your spec, and start writing these rules before you even start writing the code, and then run them as part of your CI or run them as nightly jobs to see if you're violating these rules that should never be violated as you're developing your code. One of the other limitations, or not limitations, but things to keep in mind, is the fuzzed inputs that Forge is giving you, as I said, tend towards the edges, towards 0 and towards the maximum values. You're not getting true randomness in those values. Most of the time that's not going to matter, but it's something to keep in mind. How can we take this further? We can build out more invariants, more rules. There are other things that have to always be true about the DAI contract by itself. There are other things that have to be true about the whole multi-collateral DAI system, and you could start building integration tests where you have invariants that apply to the DAI contract and invariants that apply to the multi-collateral DAI system as a whole, and run those against the protocol. If you need randomness, true randomness, or if you need less randomness, you can start to kind of put your finger on the scales to prefer certain actors do certain things, or prefer certain values come through in your functions. And that can add some really powerful ways of checking your invariants and making more successful calls more frequently, which can mutate the state faster in your protocol and maybe get you to more interesting end states. As I said, you can run these on overnight jobs for like really long depths or multiple runs and see what you get when you wake up in the morning. So that can be a powerful kind of let your code work for you while you're sleeping type thing. You can add them to your CI and run them in the cloud so that they're part of your development workflow as you check in your pull requests. And yeah, I think that they are really, really interesting ways of improving the security of your smart contracts. Adding a new tool for your testing environment. And I hope that this helps get you set up and let you run tests, build out your first invariant suite, add it alongside your unit tests. The code, all the code that you saw here on the different branches is available on the GitHub here on the screen, or at my Twitter if that's easier for you to type in. You don't have to type so much. So thank you very much.
Okay, so hi everybody. I'm Michael. I'm head of research at Chorus One. We're a staking provider with now more than $3 billion in stake. And I want to talk about timing games today. I'm presenting a paper which we wrote earlier in the year. It's called The Cost of Artificial Latency in the PBS Context. And it's basically about what happens when validators delay bids. Let's take a quick look at the agenda. So 3 major points. I want to start by defining what timing games are, why validators would play timing games, and what upside, so what financial upside validators could capture by delaying bid selection in a timing games context. I'll then talk about negative externalities that might arise from timing games. I think there's 3 major categories here, and we'll take some time to walk through all of them. And then lastly, I'll talk a little bit about our timing games pilot. So we take an accelerationist point of view here. And we've been kind of testing out timing games since the summer. But for us, it was important to balance rational competition with ecosystem alignment. And for that reason, the study that I'll present today basically open sources all of our parameters and kind of makes it open for other people to look into and to potentially imitate if that's what somebody's looking to do. So why play timing games? There's a certain dynamic, which is as the slot progresses, more transactions hit builders. So they have a larger pool of transactions, which they can use to build an optimal block. And secondly, statistical arbitrageurs are able to quote wider and more aggressively, right? So if you were to arbitrage, let's say Uniswap against Binance, and you were to do that at the beginning of the block, you would have to be reasonably more confident about what you think the price is going to be by the time your arbitrage settles than you would have to be if you would execute this arbitrage closer to the end of the slot. And what that means, the upshot of that is that blocks become more valuable in expectation due to basically transactions and by proxy MEV accruing at the builders. And the graph that you can see on the right side here is when validators usually select the next block. And in the next slides, we'll look at what that would look like in a timing game context. So let's set the stage here by putting a number on the upside. If a validator were to delay its bid selection to 950 milliseconds in the slot, this will, and we will assume that execution layer rewards are approximately 30% of all rewards. That basically means a APR upside of 1.67% in expectation. And what that means is, it's starting to get quite significant, and people would be incentivized to do something like that. This could reflect in different ways, depending on how big you are as a node operator. If you're a large node operator and you kind of pool your rewards across different clients, or let's say you have 13% of the voting power, which really would make you a very large node operator, then kind of the volatility that is inherent to MEV, it would smooth out a little bit. And you would have a pretty good idea of what you could earn by playing timing games. Whereas if you're a small validator, MEV rewards, but mentioned, are very volatile, you would be situated at a different point of the risk-reward curves. What would happen is that your rewards would vary a lot more. This is both a way of kind of reflecting the law of large numbers, which means if you run either a lot of validators or you run them for a long time, you would be approximately looking at the same result in expectation, right? One thing we argue in the paper is that this theoretical assumption is actually not reflected in practice. And the reason for that is that timing games impose several negative externalities, which disproportionately hit small validators. And with that said, let's go to the next section and talk about these 3 big categories of negative externalities. The first point here is excess burned ETH. Basically, the dynamic that underpins that is as the auction progresses, the gas price in expectation rises, this reflects on the next slot, which means that the ETH burned in the slots that are subsequent to a timing game slot would be higher than you would expect it to be without the timing game type dynamic in play. And the upshot of that, again, is that it's a negative externality, which disproportionately hits small validators, because it puts them on a worse point on the risk-reward curve. These things don't really smooth out as quickly. And yeah, so there's two consequences of that. It basically cuts into the profits of the next proposer, and the upshot of that is a zero-sum game. So if everybody plays timing games, what happens is that the slot basically just shifts backwards. In a way, everybody would be cutting into everybody else's profit, and at the end of the day, you would just be redistributing the pie. But if you're really small and you can't compete because of resource constraints that we'll go into later, or because you're very aligned and you don't want to play timing games, you're basically subsidizing people that feel a bit more liberal about that. Yeah, and for excess ETH burn, the median increase for the slot subsequent to a timing game slot. And again, here in the theoretical part of things, we assume that somebody playing timing games means that the get header request gets delayed to 950 milliseconds in the slot, just to recap that. The median increase of burned ETH works out at 0.4% in expectation, which is reasonably large, and that's the reason why we wanted to address that as a negative externality, which is in expectation quite significant. Let's go to the next negative externality, which is basically based on the same dynamic. As you delay your get header request, as you play timing games as a validator, the amount of transactions that might accrue to your slot, they increase in expectation. And another way of saying that is transactions that may have been included in subsequent slots actually land in the current one, which is the slot that would be affected by timing games. So again, this is another way of describing the zero-sum dynamic. And it's just to say that, you know, if you don't engage in timing games, it's going to decrease the rewards that you can expect as a validator. So let's recap that by specifically naming what the upshot of that would be, right? It's an increase in centralization pressure. Large operators in a timing node operators in a timing game context benefit from comparatively higher APR at lower variance. And small node operators, on the other side of things, are disproportionately increased to variance from the long tail of bad externalities. Let me just recap the ETH burn example here. And secondly, small node operators might not even be able to engage in timing games at the same amount of expected utility in the first place. And there's a couple of reasons for that. One is lack of internal data. If you're a big node operator and you have a ton of validators, you have a way of getting of just accruing more data and forming a stronger opinion of what an appropriate latency parameter would be. Whereas if you're a small validator, it just takes you a really long time to kind of find out how you can play timing games efficiently. And if something changes, if a relay were to start behaving differently, for example, it would take you a disproportionately longer time to change your opinion than a large node operator would have, right? So there's a big centralization factor here. And then something which kind of comes in tandem with that is just the fact that large node operators are typically better capitalized, so you can have people spend time on this stuff, right? And the risk here is basically centralization on the one hand, and then on the second hand, secondly, this risk manifests as a self-reinforcing cycle. Because if you don't play timing games at all, you're again disproportionately exposed. So node operators are compelled to employ latency optimization, play timing games as a matter of strategic necessity. Okay. With that said, let's look at what our approach has been here. In the summer, summer of 23, we started to play around with a timing game setup. We named that Adagio. My co-author on the paper is Italian, and in Italian, if you were to play a musical piece, Adagio, it would mean that it's performed slowly and with great expression. So we kind of named it Adagio as a nod to just going about calling get header slowly in a very thoughtful manner. Yeah, and so this has not been a client-facing product for us, but more of an internal research initiative that ran on our own validators. Now, as soon as we kind of came to conclusions there, which seemed statistically significant for us, we did two things. On the one hand, we outsourced our data and we outsourced our initial parameters. So again, this is the study I'm presenting today, and if you're interested in this, find the study. It's on our website, chorus.one. And then secondly, we kind of acknowledged that the timing games were something that would just happen with the way PBS is currently set up. So if you're competing rationally, you probably would have to engage in this type of stuff. And so we went very public with it, and we started implementing it in client-side infrastructure. But at the same time, for us, it's important to emphasize three things, right? Firstly, we don't run parameters which would expose anybody to access risk, either the network or clients. Secondly, we frequently publish our research, and we try to go about this whole thing in a transparent manner. And then thirdly, liquid staking services, like Lido would be the first that comes to mind, to us is neutral infrastructure. So this is not a place where we would ever engage in this type of latency optimization. Let's set the stage here. Our pilot basically employed different setups for different relays. Just in practice, I think I alluded to it earlier, the way you play timing games is you call the get header request a little bit later, right? So if in your slot as a validator, you would have to tell the relay that you want to receive a block now. That's a so-called get header request. You would call it a bit later. Our Adagio setup speaks to several relays, and we put them into different buckets. There's the benchmark setup, which is a relay for which we don't run a latency parameter at all. There's the aggressive setup, which is a relay for which we delay the get header request as much as reasonable possible on a risk-adjusted basis. So not as high as the theoretical expectation of 950 milliseconds, but slightly below that with a risk margin, still rather aggressive. And then there is what we christened the normal setup, and that's basically a latency parameter which is a bit below the aggressive setup. Okay, and the moderate setup, that's just then again another step below that and super conservative. In the box plot here, you can see what that looks like. If you look at the right side of the box plot, you kind of see what Adagio started to do after we implemented our parameters. And let's consolidate that into one graph. And what you see here is how the network usually would solicit get headers in expectation. So that's a box plot with a rather large margin around it, and then what Adagio would do. And if I had to put that into words, I would say that Adagio calls get header a little bit later, but it does it in a manner which is very risk aware. So the spread of that is rather small, right? So if you play timing games, I think it's very important to go about it in a manner which is very consistent and which is risk adjusted. And in quantitative terms, you would say that you want to reduce your variance there. And I think we did that quite successfully. Let's look at how this practical type setup compared to what we would have expected in the theoretical part of our study, which again is a latency parameter of 950 milliseconds. So these graphs are quite closely clustered together. You might not be able to see it from the audience or on the stream, But basically what happens is that Adagio actually did slightly better than what we would have expected in theory. And so let's conclude by putting a number on it. The network distribution of payloads basically is a mean of 0.0467 ETH per slot. You can see the quantiles below here. I'm not going to read it out, but of course there's a fair amount of variance. And the Adagio payloads have a median which is quite significantly above that, right? Again, I mentioned variance, so this is a data set which is of a reasonable size, but it's not something that we've been running on for years. I think the upshot here is just that it is something which has affected our bottom line meaningfully, and I think so despite remaining below the 950 milliseconds, which we quantified the theoretical expectation with, Adagio outperformed the amount of revenue which we would have expected. So let's conclude here by providing a quick outlook. There's a couple of reasons why Adagio did better than what we would have expected in theory. And we do have a lot of data, so we are looking at rolling out Adagio 2.0 now. And for Adagio 2.0, we would be making some of these dynamics more explicit, which kind of helped us outperform the theoretical expectation there. I think the first insight is that the usual way timing games are described is you basically have a latency parameter, and this is what in the kind of in our context there, taking a step further, is described as naive parameter-based optimization. What we acknowledge there is that the MEV boost auction is not consistently timed. So Adagio 2.0 dynamically adjusts for divergences, right? And the fact that it's not consistently timed is definitely a reason why we outperformed the theoretical expectation. And we kind of found an approach which we think allows us to adjust for this on the fly and do even better in this regard going forward. Secondly, we, as I mentioned, have a lot of data, and we noticed a small but significant performance difference by geolocation and by data center, right? So what you want to do here, of course, is you want to run in spots which look more attractive relative to other spots. And specifically in the context of Adagio 2.0 and timing games, that means that it now optimizes for network latency in a few ways. And what I mentioned at the beginning of the talk is, that we are committed to being very transparent about that, to kind of, balance alignment with competition. So expect news. Expect us to publish, more specific takeaways once we feel the statistics are in a good place that makes us reasonably confident in what we are theorizing here. And then the last point I want to make is some of the learnings that we have had on Ethereum. So for example, I would highlight the last point here in terms of network latency optimization. They might also carry over to other networks. So again, it's quite early days, and I don't want to say anything that doesn't seem statistically certain. But we've looked into some other networks, and we think there are definitely takeaways that would not only work in an Ethereum context, but maybe on other chains as well. That's it. The outlook kind of concludes the presentation. We've published all of this on ETH Research. It was really important for us to make sure that people are aware of these externalities and kind of to trigger a discussion there. So if you're interested in that, feel free to scan the QR code. This presentation is also on our website, and I think we are tweeting it as well. So if you don't want to scan it now, feel free to catch up with that later. Join the discussion. If anything here sounded interesting or relevant, feel free to find me after the presentation. And that's it. So have a good conference, everybody.
Hello, everyone. Welcome to The Future of Ethereum Starts with Open Source Education. My name is Tina. I am one of the UETH core team members. We'll talk a lot more about what UETH is, but first, let me introduce you to some of my colleagues. We have Satu, who is also a UETH core team member, Sai, who's our UETH visionary, and Colton, who is the founder of ACE TCG. So for this session, we're going to get started making the case for why open source education. Then we'll tell you a lot more about our work that we do here at UETH, as well as the underlying philosophy that we're taking. And finally, we're excited to unveil a strategic partnership with Colton, which he will talk more about. So I will get started with the case for open source education. I think the case is quite obvious. Digital literacy is very crucial in navigating the Web3 space safely. When people come and they have to actually own their assets and navigate scams, there is a widespread need for blockchain basics. And so while there's a ton of content out there on crypto Twitter, on Medium, Substack, Farcaster, users have to really sift through this content and understand exactly what is quality and what is credible. And simultaneously, we have numerous numbers of blockchain chapters around the world that are taking this task on of educating and onboarding Web 2 to Web 3 users. But they all have disparate access to not only content, but also the speakers that they're able to bring in to educate their community. And finally, we've heard a lot of our chapters have this challenge of up-leveling because they have to focus on sort of the operational tasks in basic blockchain education, and they don't have the resources to up-level their chapter goals or gain any global recognition. And so we are the University of Ethereum, UETH for short. Our core mission here is to develop and empower the next generation of blockchain leaders. And how we do this is we provide the global community with open access to educational resources that we consider the operational piping for them to focus on more high-value things. And so let me give you a pretty concrete example. I live in Austin, and in Austin, there is the University of Texas, which hosts a MBA blockchain club, as well as a separate undergraduate club. Within Austin, there's also a ton of city organizations like ATX-DAO. And all these clubs, whether or not they start for social reasons, educational reasons, or other reasons, all end up having to onboard Web 2 to Web 3 users. And so they all have this need for blockchain education. So one thing that we're providing for them to lower the burden of their focus on blockchain basics is we provide this online educational library for anybody and any of their members to access. Simultaneously, we have this global community hub, which they can use to run their chapters. And we provide weekly speaker-led workshops. And these speaker-led workshops tap into our networks, which will attract generally pretty prominent figures in this blockchain space. So for instance, I've been a crypto VC, most recently a Variant, and Sai and Sabrina have hosted EdCon, which is the Ethereum Developers Conference since 2017. And so a lot of the speakers that we're sourcing, these general blockchain chapters do not currently have access to. But I think, above all, the most important thing that we're doing is we're shifting focus from the operational tasks of providing blockchain education, of organizing speaker-led workshops from these chapters and shifting them to more high-value things like learn through doing projects. And these projects are either projects that they can join when our speakers are coming through and offering contribution opportunities, or projects that they may be inspired by our workshops when they see real-world use cases of how blockchain is applied, and coming up with their own inspiration and starting their own blockchain projects. And finally, I think the biggest part that we offer a lot of these chapters is when they do have a project that matures and wants to graduate to the broader blockchain community. Right now, there's no scalable way for them to compete for global attention. And so by hosting in real life events such as the Ethereum Developers Conference, we're able to plug in these localized communities and the projects that they're working on directly into the Ethereum community. And I'll just end on a quick snapshot. We've been conceptualized, we've been around for about 2 years. We have over 100 different chapters across 100 different plus countries. And we have a pretty strong offline as well as online footprint. So with that said, I'll hand it off to my colleague, Sabrina, who will now talk more about exactly what we do.
Awesome. Thank you, Tina. So I will proceed to touch upon some of the tools we've been built to onboard and empower future leaders. So I'll start with our interactive learning platform powered by AI. If you guys go to UETH.org or check out the visual references over here, you'll be able to find Duolingo-style analogy-based learning modules covering the fundamentals of the blockchain technology. We also have AI tools to assess our students' performance by grading their quizzes and facilitate their learning process. So with this, we really hope to establish the new standard for Web3 literacy, as well as digital literacy in general. But this is only phase 1 for us. The next step for us is to invite our partners, such as projects or communities, to build through our education infrastructure and build their own education content for their own set of audience. This is what we call white label solutions. And stage 3 for us is to truly make our platform open sourced. So anyone, including communities, projects, individual educators will be able to contribute their expertise of knowledge to help us co-build, co-create this interactive version of Wikipedia page of the blockchain space. So many of the students, after they finished the onboarding series, they came to us with the question, what's next? What else can I learn? And how can I really solve real-world problems through blockchain technologies? That's when we design the weekly interactive workshops for them to advance their learning process. So what is our version of workshop? Our workshops are led by industry leaders, and students are encouraged to brainstorm new solutions together with the speaker. So Tina has been working on a few of the workshops with industry leaders from the esports gaming industry, as well as expert of creator economy. Recently, she just finished an episode with our guest from Stability AI to further explore the synergies between AI and crypto. And our very first workshop, hosted by our workshop host, Rachel, was with the Vice Mayor of City of Berkeley and Princess Sarah of Sierra Leone. Through this workshop, our students were able to explore internship opportunities with the Office of City of Berkeley, as well as understand how blockchain bonds can be applied to clean water initiatives of Sierra Leone. So through the workshop series, students can get to understand what's beyond aspirational potentials and really brainstorm and try to build projects with their peers. What we can offer for students who want to build their projects is a serious support through our global community hubs. So if students teamed up with their peer that they met through our platform or previously through local communities or university blockchain clubs, they can submit their projects, and we will be able to provide mentorship support, grants opportunities, as well as exposure at our own events. So to recap, the Learn by Doing journey starts with learn the basics at UETH.org. And then if you want to learn more advanced topics and understand how you can apply blockchain technology to solve real-world problems, you can join our workshops. And then you can team up with your peer and work on projects. later you'll get the opportunity to present at regional and global events that's hosted by us. So I've touched on solutions, how can students get involved, and how can we support them. I'll now pass the mic to Sai to introduce, explain more about our ethos, our philosophy, and what is the fundamental layer of UETH. Welcome.
Thank you, Satu. Thank you, Tina. Oh. All right. Let's not overcomplicate things. Ethos or fundamentals. Let's talk about what we can identify that's currently going on in the space. The negative constructs, the negative narratives, the negative connotations. How this space has become a financial vehicle for degens. We have a lot of education initiatives that covers learn and learn type of programs where they are incentivized through monetization. And I believe that's the worst way to educate or to start any educational initiative. So personally, I believe what you put in is what you get out. And if we want to create and inject creativity, we have to inject it with creativity. To carry the values of what open source is, transparency, inclusivity, community building, sharing of resources and knowledge, learn by doing, and being accessible. So going along the narrative of a financial vehicle, I believe that people come into this industry for the wrong reasons. They don't stick around long enough for there to be social awareness or social responsibility. We want to form a fundamental layer that give our students and our members the tools, the right tools, for them to have both the tangible and the intangibles in order to build regenerative pipelines. Raising the benchmark of digital literacy. Part of making content that's accessible as possible is to make it fun and as relatable as possible. Sabrina touched on how we use AI tools. That concept is based on the Feynman technique, where essentially is you don't know something well enough unless you can say it in your own words. We wanted to create a standardized curriculum where anyone from 5-year-old to 50-year-old is able to understand it. So we took about 160 or so core concepts to the Ethereum blockchain and created storylines taught through analogy. And we wanted to showcase a new way to educate by localized content. Meaning, by no means are we educators, but we want to provide a different approach to how things can be taught and how things can be learned. And most people, when we ask, are you interested in blockchain, or what do you think about Web3? Is a lot of times we get that it's not that we don't care or we're not interested, is we don't know where to start. So at the University of Ethereum, we want to consolidate the resources that we have collected. We want to be able to extend our hands out to anyone who needs and wants to get started in this space. Another thing that we're doing is these weekly workshops, which is essentially spotlighting everyone who's building blockchain and using blockchain tools to make impact in their community. We want to showcase what they're doing around the world, so our students can begin to know what's possible and how they can begin to make impact regardless of scale, regardless of industry. We want to create this fundamental layer that instills moral fiber, where it's a safe environment where you're able to fail, you're able to try, and you're able to have access to dedicated mentorship. So you have the tools and the confidence to be able to succeed. And one of the use cases that we believe can help build a more positive narrative in the creative collective space is ACE. And next, I want to invite Colton to come up and share what he's working on.
Amazing. Thank you, Sai. Hello, so I'm Colton. I'm the founder of ACE. ACE is a trading card game about the magic of Web3. So every card in ACE represents real-world innovations and the heroes and villains behind them. So picture all of your favorite crypto themes, memes, the protocols, people, and projects, and then transform those into sci-fi and epic fantasy cards. So we think of this as metaverse mythology. And the coolest part is that these cards are actually created by the community, by people like you. Before I get to that, though, how did we just go, or why did we go from talking about education to now talking about a game? Well, as my colleagues just talked about, digital literacy is lacking overall. And the blockchain space in particular is extremely complicated. There's a lot to wrap your head around. It's a super fast-moving space. And especially if you're just getting into it, it's just easy to get scammed and totally overwhelmed. So Yuval Noah Harari has this quote that I absolutely love. It says, "Humans think in stories, and we try to make sense of the world by telling stories." And ACE presents a story that uses these 5 different colors, each color representing a different philosophy in the crypto space. And these create a sort of mental model. And what I really wanted to go after here was just creating the most fun and engaging way possible to learn about the blockchain space without feeling like you're learning anything at all. So let's dive into a couple of these. We'll start with the good old degens, the red cards. So anybody who's played trading card games before, you may be used to like more aggressive aggro style decks. These are going to be your degen red cards. So these are your very chaotic sort of just immediate action and like just you're going to be really strong at the beginning of the game, but maybe taper off late game. Across from red, you've got the regens. Maybe not so strong at the beginning of the game, but super powerful late game. A lot of the cards will represent maybe names that aren't so popular in the crypto space, but they're all the people and projects that have been around for years doing really, really great work. In gold, we've got a lot of your more traditional institutions, the banks, the centralized exchanges, some of the government institutions. These often are represented by more sci-fi and sort of very futuristic technologies. And across from them, you have the real magic, blue, focused on freedom, innovation. A lot of the cards here will represent the actual Web3 and crypto things you'll see around a place like ETH-Denver. Finally, you have the black category, the shadow. These are all of the other philosophies taken to an extreme. The corrupt versions of each of them. And while a lot of these are really fun and flavorful cards, they can be quite sad if you lived through some of these moments. So here we have some of the contagions, the frog commanders, the dark personalities, and of course, anyone who's familiar with Slate Star Codex and the demon of coordination failure, you've got Moloch right on top. So as I mentioned, many of the most popular cards in the alpha edition of ACE were created by the community. And one of the things that I'm really, really excited about right now is that huge thank you to Jmill for coding this up. We now have a very early version of the web app for you to actually make your own cards. So until now, I've been a bottleneck in this process where I just meet with small groups of people. We do some creativity games. We vote on different cards. It's worked great, but now it's a much more permissionless process. So you can join the Discord, you can jump right in, and like I said, to capture the incredible, vibrant diversity of crypto, the only way we can do that is by everyone adding their own perspectives. And just as an artist and a creative, it's one of the most thrilling things to see is how all of our perspectives weave together. So I certainly invite you to drop some cards in, and really excited to see what you come up with. That's powered by Eden. Really, really cool tech. So the last part here that I'm going to touch on is just where this project came from and where we're going. So 1 year ago, I came to ETH Denver with an art project. There was no game at the time. It's called the Infinite Garden Cards, and it was 20 of these collectible cards. I handed those out, and after ETH Denver, over the following 12 months, my brother and I created the entire trading card game. We sold out at DevConnect in Istanbul, and now we're partnering with the University of Ethereum to bring you the digital version. I'm really excited about this transition into the digital space because it is going to just make this so much more accessible to people. And as an educational resource, that's something that's just really, really important to me. So both in terms of the educational element and this sort of idea of like learning by doing, these are two themes that we share between UETH and ACE. And again, I invite you to join this adventure, and I'm really excited to just see the game that we can create together. So thank you very much. Pass it back to you.
Thanks, Colton. I know you'll be in the main event. You'll have a booth set up there, so he'll be selling more of his sold-out cards that he's reserved for ETH Denver. So you can grab a deck and play the game. So that was the end of our talk. I'm just going to conclude on a few points. Here's all of our socials. But the one thing I want to say is we're constantly looking for Ethereum leaders to feature in our workshop. So if you have an interest in giving back to the community, talking more about what you're doing with blockchain, feel free to email us, lead@ueth.org, and we can get a conversation set up to see if it could be a fit. We are also interested in creating a mentorship network. So feel free to email us if you have any interest in mentoring any of the projects that come out of UETH. And finally, for ETH Denver, we have a few cool things. We have a booth set up at the entrance of this arena, so come find us. We are participants in a POAP challenge where you can mint your POAP and then start your UETH trivia. But I think the other cool things is if you wanted to try out our online workshop or our online modules on blockchain basics, if you finish the beginner course, which is about an hour, come find us at our booth and we'll enter your name into a raffle for one of 10 signed Vitalik t-shirts that we will raffle off at the end of ETH Denver. And then 2, if you finish our intermediate course, which will take 2-3 hours, come find us, and we'll give you a comped ticket to EdCon, which is taking place in July, end of July in Tokyo this year. So come find us, and that was our talk.